Right. So I think right, last class we done something. So I think the next one is this only. This is the problem which I already written. Right. Please go through it. So let me read the problem one time. Let G be a connected planar graph with 10 vertices. If the number of edges on each face is 3, then the number of edges in G is. It is a given problem. Can you try whatever possible by you? What is the meaning of face? Face means region with 10 vertices. If the number of edges on each face is 3. Yeah, face means I think right, region. Then the number of edges in G is. Can you try this? Whatever you know, supply. Nothing there. You may give answer, you may not give answer. Are first time itself how you give answer, yeah. First time itself how you give answer. Try. Maybe you will give. If you give, well and good. If you don't give, it's okay. Someone is giving answer, sir, I am not able to give, sir. They done maybe previously. Someone is saying 24. Yeah, let's try. Let's try this. Yeah, let's try this. So can you help me now? Can you help me now? Can you help me now? What is the degree of every region? What is the degree of every region? With 10 vertices, if the number of edges on each face is 3, oh, degree of every region is 3. Can you help me now? Can you help me now? See this one? Can you help me now? Everyone listen. Everyone listen. Sigma I is equal to 1 to some. Let us that some regions are there. Which regions are there? I is equal to 1 to R. R regions are there. Degree of region 1, region 2, region 3. Assume maybe K regions. Some number. R1, R2, R3, R4 and so on K. Right? Degree of region 1, degree of region 2. Can you help me now? This will equal to how much? Is it 2E? Sum of degrees of a region is 2E. So, and one more thing I am writing here, assume R regions are there. Assume R regions are there. So R1, R2, R3 and so on, like that R times. Can you help me now? So this will goes to, can you help me now? This is equal to, can I say like this? Can I say like this one? Every person, every region degree is 3. Can I say 3R? Every region degree 3. 3, 3, 3, 3, 3. Degree of R1, 3. Degree of R2, 3. Degree of R3, 3 and so on, like that R times. right? Is it 3R, which is equal to 2 into E. Sum of degrees of regions is equal to 2 into E. Yeah, maybe you can write K also, R also, whatever you want. But let me ask you one small and why are you writing KV like that? Listen everyone now. That 3 is degree of a vertex or degree of a region. Confirm me first too. Degree of a region, not V. If at all 5 regions are there, every region degree 3, 5 times. It is not a degree of a vertex. It is the degree of a region. Assume R regions are there. Assume R regions are there. Right? If you want, you can keep R also. I don't have any problem. Use whatever notation you like. Because if I thought same R's are there, you may be confused. Region Ri. Like that R regions are there. So everyone is 3, everyone is 3, degree of R1, 3, degree of R2, 3, and so on R times. Okay, that is fine. Everyone knows this. From the given information, this is the one which I got. And one more thing is because of planar graph, can I write this one? V plus R is equal to E plus 2. Can I write? V plus R is equal to E plus 2. Can I write this also? Connected planar graph. It is number 2. Right? So if you observe clearly, this R can be written as 2 into E by 3. And one more, is he mentioned how many vertices are there? 10 vertices are there, he mentioned. He is asking number of edges, how many? Convert everything into edges. Convert everything because you want to finally number of edges. Convert everything is in the form of edges because you want finally E value. So now if you substitute, this may be 1. Now if you substitute, right, substitute into substitute 1, then it is going to be V plus R is going to be 2E by 3. 2E by 3. If capital, small, it's up to you. Right? All right capital or all right small. So I'm changing this one. Right? 2E by 3, which is equal to E plus 2. What is the V value? I think he is already given 10 vertices. 10 plus 2E by 3 is equal to E plus 2. So finally, if you write properly, right? So this became 30 plus 2E, which is equal to 3E plus 6. Do proper calculations. 2E will go that side, right? 2E will go this side. This is the 30 minus 6, which is equal to E. Finally, E is equal to 24. Do whatever way you like. Into substitute 1. In the place of this R, I kept this. In the place of V, I kept 10. Right? So degree of one region 3. I have R region, right? R into 3, which is equal to sum of degree. Sum of degrees of region is equal to 2 into E. R is equal to this because I want everything in terms of E. So I want to get finally E value. So I converted. See, R also I written in terms of E. E already there in terms of E only. But V will go because of E is given. So finally E value becomes 24. If you okay, we can move to the next problem. If you okay, we can move to the next problem. Can I move next? Check anyone having any doubt. Sir, I have this doubt, sir. You ask me, I will help you. Let me give this also. Next problem. Let me give next problem. No need to by heart. No need to by heart. Whenever you are solving next time, listen, whenever you are solving next time, see the problem only, don't see the answer. You are solving next time, see only problem, don't see answer. You try your level best. If you don't get, lastly you see. Some people, what they will do is, they will study question also, immediately answer also. They will think that everything is okay. And if you see the question and the answer, everyone okay. In life also, God is giving problem. Immediately answer also is showing. So what is so great? Let us assume that in your life problem came. God is given immediately answer also. Then what test it is? What test it is, yeah? What is the purpose of that test, right? Problem is problem. Don't see the answer. You do by yourself. What is the planar graph? What formulas are available? What he is asking? Plan accordingly. Some people say problem, they will see immediately answer also will see. Okay, problem sahiye, answer sahiye, problem sahiye, answer sahiye. Finally, GATE examination, right? Final GATE exam is not sahiye. It is not right. It is not sahi hai. Not sahi hai. Bhaiya, last exams no sahi. Yeah, fine. Yeah, I'm writing the problem. Let me write. If G is a forest. If G is a forest with n vertices. With n vertices. If G is a forest with n vertices and k components. If G is a forest with n vertices and k components. K connected components. Then how many edges does G have? This is the given problem. Can you try this? If G is a forest, with n vertices and k connected components, then how many edges does G have? Yeah, think about and try to do. If anything new, I will explain. Yeah, can you help me now? G is a connected one or disconnected one? G is a graph, okay, connected or disconnected? I want to get clarity from your side. G is connected or disconnected? Are k connected components are there, yeah? How G is connected? G is a forest with n vertices and k connected components. G having these many components. How G is connected, yeah? Yeah, now give answer. G is a connected graph or a disconnected graph? G is a connected graph or a disconnected graph? Give the answer. What is the answer? It is a disconnected. So let's see this. Let's see this one. It is a G. It is a G. which have, let's see this one, k connected components. Let us assume that it is the one connected component. It is a one more 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 connected component. Assume. So it is a G. G is a forest with n vertices and k connected components. Can you help me? What is the k value? Read properly. I drawn the diagram also. Can you find out k connected components? What is the k value? 6. Yeah. And one more. See this one. See this one. Let us assume that it is having 4 vertices. It is having 3 vertices. It is having 5 vertices. It is having 2 vertices. It is having 1 vertex. It is having 6 vertices. Can you help in how many components? How many components? 6 components. 6 components. Next one. Can you count how many vertices total? You said 6 components. I am happy. K components, K value 6. Can you count total vertices? If G is a forest with n vertices, he said n. N means how many? Count once. 4 plus, I think 6 there, 4 there, 10, 5 also there, 15, 15 plus 3, 18, 18 plus 2, 20, 20 plus 1, 21, 21 vertices. Are you okay? And one more. It is a component K1. It is a component K2, component K3, component K4, component K5, component K6. Total graph name is G. Now see the interesting, this is the major key point. This is the major key point. Listen, some people are thinking that, right? Rajbhai are thinking that it is something like sabji, something like, I think, a nice meal, bhaiya control. Sir, it look like a nice sabji and dal rice. It look like a dal rice, sir. Reddy sir, it look like a dal rice. So many items are there. So many items are there. Shakir is saying, yes, I will take that sabji, right? Dal sabji, dal rice plate I will take. I will keep on your face like this. Arey Shakir, I will take that plate, total plate, all items are there. I will keep on your face like this. Then I will ask, what is the taste? Right, anyhow, come back here. K value 6, n is equal to 21. Everything is ready. Please give answer. Please give answer to me. G is a disconnected graph or G is a forest? Very interesting thing. G is a forest or G is a disconnected graph? This point try to catch. This point try to catch. G is a forest or G is a disconnected graph? G is a forest or not? He mentioned. If he say G is a disconnected one, if he say G is a disconnected, then G is a disconnected different, G is a forest is different. Some people are asking, so what is the difference? Let me check. I will do clarity. Can you say K1 component having how many vertices? K1 component having how many vertices? 4. Array K1 yaar. K1 component having how many vertices? 4 or not? 4 vertices are there. Observe here. K1 component contain 4 vertices. I am very happy, right? But can you help me with the 4 vertices? Maximum how many edges possible? K4 with 4 vertices. Maximum how many edges possible? K4. What is the answer? 4 into 3 by 2. 12 by 2. I think 6. Am I right or not? But remember, G is a forest means, every subgraph is a tree. every subgraph is a tree, remember. You cannot write the 6 edges. You have to write 4 people, 3 edges only. Remember, when you say G is a forest means it is a disconnected graph. But remember, every component is a tree. That is the meaning of forest. Forest is nothing but collection of trees. Forest is nothing but a collection of trees. Are you getting? Forest is nothing but a collection of trees. Some people are thinking disconnected graph is a forest. No. Disconnected graph is not a forest. Remember. Right? When you say forest, every subgraph is a tree. I think, do you believe or not, whenever you are studying algorithm subject, right? I think if you see the Prim's algorithm and Kruskal algorithm, can you say Prim's algorithm, Kruskal algorithm, who is continuous? Every time connected. Prim's, if anyone, those people who studied, those people who remembered, please let me know. Prim's algorithm, Kruskal algorithm, who is continuous? Always adjacent, always adjacent. Prims are not. Kruskal is a disconnected one. First of all, Kruskal and Prims both will give spanning trees. But in the case of the Kruskal algorithm, disconnected spanning tree. What is the meaning? I think small trees. So I think Kruskal algorithm will give like this one. 2 people connected. Sometimes 3 people connected. Sometimes, right? Sometimes 4 people connected. So like that, it will give trees. It will give trees. Lastly, all are connected. Lastly, all are connected. Intermediately, it is behaving like forest. If anyone asks you, Prim's algorithm, Kruskal algorithm, who will give tree at the end? Who will give tree at the end? Both. Who will give forest in between? Who will give forest in between? What is the answer? Kruskal algorithm. Kruskal algorithm in between it will generate, right? Forest. What is the meaning of forest? Collection of trees. Collection of trees is forest. So remember, when we say G is a forest, when we say like this, oh, G is a forest means it is a disconnected graph, but every subgraph is a tree. So can you help, K1, 4 vertices, 3 edges are there. K2, then what is the answer? K2, then can you help K2, then I think 2 edges. K3, I think 5 people. 4. This one, I think 1, 0. 2, 1. I think 6, 5. Is it okay? Is it okay? Now listen everyone. Then he's asking how many edges G is having. How many edges G is having? That is the question what he is asking. How many edges G is having? Can you count how many edges? Can you count how many edges? How many edges count? 3 plus 2, 5. 5 plus 4, 9. Count edges, yeah. 3 plus 2, 5. 5 plus 4, 9. 9 plus 5, 14. 14 plus 1, 15. Right? 15. Edges are 15. Can you count? What is the relation between all these 3 people? If you want, you can check. A number of edges is equal to n minus k. Am I right? 21 minus k, 6, which is going to be 15. Am I right? Number of vertices minus components, which is going to be number of edges. This is the formula between them. Just can you remember this also? If G is a forest with n vertices and k components, then how many edges does G is having? Right? So if at a connected component, if connected is not there, then also no problem. K component means meaning is same, but forest means, remember, every subgraph is a tree. Forest means the only thing I want to explain from this. The only thing I want to explain from this. Remember, forest means you may be thinking that disconnected graph. Remember, disconnected graph, okay, but every subgraph is a tree. Every subgraph is a tree. 4 vertices are there, 3 edges. So remember this. From this, the formula is number of edges is equal to number of vertices minus number of components. This is the formula. I want to say this. Yeah, next one. One more thing. Roughly I will give. Can you see this? Roughly I will give. How it came also, just I will give roughly. See this? Let us assume that here n1 vertices are there in the first component. Here n2 vertices are there. Here n3 vertices are there. Here n4 vertices are there. Here n5 vertices are there. Let us assume here nk vertices are there. Can you help in how many components? N1, right? So N1, N2, N3, and so on, Nk. How many components? N1, N2, N3, N4, and so on, Nk. How many components? Nk components. Means K components. K value 6. I'm repeating once again. K1 component, K2 component, and so on. K components are there. Now, those people who are confused, remember that red color is vertices. Let us assume that first component having n1 vertices, second component having n2 vertices, third component having n3 vertices, and so on. Last component having nk vertices. n1, n2, n3, and so on, nk. Right? Fine. These many. Now, can you help me now? If this one is having n1 vertices, right? Listen, this one having n1 vertices, because of it is a forest. How many edges are there? n1 minus 1 edges, 1 less. Because of it is also a forest, right? What is the answer? n2 vertices minus 1. It is also n, right? n3 vertices minus 1. It is also n4 vertices minus 1. It is also n5 vertices minus 1. It is also nk vertices minus 1. I think if you add all these edges, what is the answer? First one, n1 minus 1 edges plus n2 minus 1 edges plus n3 minus 1 edges, and so on. Lastly, nk minus 1 edges. I think k times, right? This can be written as, right? If you add n1, n2, n3, let me write now. n1 plus n2 plus and so on. nk minus k, because 1, 1, 1, 1, 1 k times, which is going to be, these all are vertices, right? This is going to be v vertices. So v minus k. These are the total edges. Is it okay? Total edges are these many. Total edges E is equal to this much. First one contain n1 vertices. Edges are n1 minus 1. Second one contain n2 vertices. Edges are n2 minus 1. Third one contain n3 vertices. Edges are n3 minus 1. Last one contain nk vertices. Edges are nk minus 1. If you add all these n1, n2, n3, this one, remaining 1, 1, 1, 1, 1, if you add k, so n1 to nk, total vertices came, which is v. So finally v minus k. So number of edges is equal to v minus k. This is the proof for this. Please take care next time onwards. G is a forest with k components. Try to understand the meaning. This formula also remember. I almost given proof. Anyone having any objection, you no need to by heart. Take one example and check. Most of the things in the graph theory, by taking example, you can handle. One time study meaningfully. If you forget also, you can bring it out somehow. Meaningfully one time study. Just meaningfully study one time. Otherwise, these many formulas remembering is very difficult. Yeah. So go ahead. No need to say sorry. You do your work, we will do our work. See, he written Bhagavad Gita. Kill us. Read one time, sir. I am sorry if I am disturbing class. right? These many paragraph are bhaiya, where you are listening class here, where you are listening, right? Typing only over, where you are listening. Sir, I'm sorry if I am right taking. You can skip this if you do not want to disturb the flow of class. Sir, if you have watched Iron Man, the movie in Hollywood. Array, Atul, one time, if I click on mouth, I thought it is a serious doubt about the current topic. I thought it is a serious doubt. I am so innocently reading like this. I am so innocently reading like this. Array, he's saying something about movie. He's saying something about movie. So innocently, I am reading like this. Iron Man, Giran Man, Gold Man, like brainless fellow. Current topic is perfectly clear, okay? See, Shakir saying multiverse of graph theory. You people do whatever you want. You kill each other. If anyone is alive, let me know. Shakir and Atul, you both kill each other. After class over, you both kill each other. Anyone survive, let me know. Who is the final winner? Who is the final winner? Please let me know. Right. Can we move to the next one? Are you okay with this? Yeah. Bro, we will discuss after class. Bro, oh, when you both became bros, I don't know. Bro, we will discuss after class briefly. Okay. Okay, fine. Go ahead. Go ahead. See, Johan joined correct time. Correct time he joined. Johan joined correct time. See, some people want to join by seeing this paragraph, they run away. Some people almost came inside. I see almost like a number of people count is increased a lot. But by seeing this paragraph, some people dropped. Okay, fine. Chalo. Can we go next? Can we go next? Yeah, this problem, it's right. Johan, you may miss it out. Please check afterwards. By seeing this one, don't die. Johan, by seeing this diagram, you want to die. Don't die. Right? Relax. Afterwards, you can check. Afterwards, you can check. Almost I did. If you die for this, can you see the Atul message also? Can you see Atul message? Right? Can you see the Atul message? Even your Atma also will die. Not only you will die, your Atma also will die. You just see the Atul message, Atma also will die. That was interesting. You go to hell. You people go to hell. You all go to hell. That is interesting. You all people go to hell. Yeah, I'm continuing. Right? Let's see the next one. Ready? Graph coloring. Read the topic name. Graph coloring. Next one you can write. Right, start now. Graph coloring. Yeah, can you help me? If anyone knows what is the graph coloring? If anyone knows what is graph coloring? If anyone knows. It is a new topic. In the graph, whatever we covered, something, one more extra topic. Graph coloring, what it means. Yeah, coloring the graph. He's saying that graph coloring means coloring the graph. Okay, fine. Nice joke. Jaya, nice joke. Yeah, I'm giving the answer. I'm giving the answer. Everyone listen. Everyone listen. Graph coloring. Graph coloring. See this? V1, V2, V3. Careful. V1, V2, V3. Can you help? V1, V2, V1, V2. Are they adjacent to each other? V1, V2, are they adjacent to each other? V1, V2, are they adjacent to each other? Remember, what the graph coloring saying is, if two vertices are adjacent, they cannot contain same color. Let us assume that V1 color is C1, some color. If you want, you can say some color, maybe blue color. C1 is blue. If at all V1, V2 are adjacent, V1 color is C1, V2 cannot be C1, it will be C2. Next one, can you help V2, V3 adjacent or not? If V2 is C2 color, V3 you cannot give C2. And one more thing is, V1, V3 also adjacent. If V1 is C1, you cannot give C1 here. Here you cannot give C1. Here you cannot give C2 because adjacent people are already having. I think here C3. Okay, fine. No two, listen everyone now. In the given graph, no two adjacent vertices contain same color. If you can do like that, that is called graph coloring. In the given graph, no two adjacent people contain same color. Can you write the definition first? In the given graph, if two vertices are adjacent to each other, then they should have different color. Like that, if you can make total graph, then that topic is called graph coloring. Write in your own way. In the given graph, if two vertices are adjacent, then those two people should have different color. If you can do like this to the total graph, then it is called graph coloring. Fine. Now can you see this? Can you see this one? V1, V2. Observe here. V1, V2, V3, V4. Can you help Can I give everyone different color? Is it graph coloring? Just give everyone different color. Is it graph coloring? Yes. No two adjacent people contain same color. No adjacent to, right? No two adjacent people contain same color. So for everyone give different color. That is also graph coloring. So this is also graph coloring. This is also graph coloring. In the given graph, no two adjacent people contain same color. This is also graph coloring. But one thing I want to ask you, V1, V2, V3, listen everyone, V4. V1, V2, V3, V4. Can you see this one? I will give C1 color to this. Because of V2, V4 adjacent, I will give C2 here. Next one. Can you help V3, V4 adjacent, it is a C2. I can give C1 here. Next one, V1, V3 is adjacent, it is a C1. I can give C2. Can anyone help Two adjacent people contain different color. Am I satisfied or not? If two people adjacent, they should contain different color. If you want, you can check. For V1, one side is C1, one side is C1. But V2 and V3, they are not adjacent, no problem. For V4, one side is C1, another side is C1, no problem. No two adjacent people contain same color. Remember, it is also graph coloring. But the person who contain less number of colors, right? This is called as, this is also graph coloring, this is also graph coloring. But two colors only we are using. See, to color the given graph, minimum number of colors if you use, that is called chromatic number. Chromatic number of this graph. chromatic number of the graph is equal to minimum number of colors. Needed to make graph colorful. Chromatic number of the graph is equal to minimum number of colors needed to make graph colorful. How many required? To make this graph as colorful, minimum number of colors how many? 2. That is called chromatic number of the graph. Here if you see, number of colors you used 4. This is also graph coloring. This is also graph coloring. If they ask you chromatic number, not only giving coloring, minimum number of colors you have to use. Right? Let me give the numbers. G1, it is the G2, it is the G2. For the G1, if you give blindly, 4 colors required. If you use a little bit of common sense, 2 colors are enough. So for the G2, right, chromatic number of the graph is 2. For the G2 graph, chromatic number of the graph is 2. Whenever 2 possible, definitely 3 possible, definitely 4 possible, definitely 5 possible. Can you help me now? Are you giving color to vertices or edges? Are you giving color to vertices or edges? Vertices or not? This is also called as vertex coloring. This is also called as vertex coloring. If you give coloring to edges, that is called edge coloring. Chromatic number means vertex coloring only. Minimum number of colors required to make the graph as colorable. Chromatic number means vertex coloring. Don't worry about the edge coloring. In the given graph, no 2 vertices contain same color. If you can make total graph like this, then I can say graph coloring is done. To this graph coloring is done. Next one, right? So suppose isn't that for the given graph, you given 5 colors. Someone is given 3 colors. Then comparing you 3 better. Suppose isn't that less than 3 not possible. Then it is called as chromatic number of the given graph. To make graph as colorable, you used the minimum number of colors. So how many you used? That is called chromatic number of the graph. Chromatic number of the graph is nothing but minimum number of colors needed to make graph as colorable or colorful. Right? So remember, vertices we are giving colors, vertex coloring. Anyone having any doubt? Anyone having any doubt? Write in your own terminology. Just this topic, just think about this only. Previously, we discussed about planar graph. We done some formulas, some problems you done. Now graph coloring is going on. No 2 adjacent vertices contain same color. If you can do like this for all vertices, so graph coloring is done. Next one, suppose 5 vertices, right? 5 colors you used. Someone used only 3. Someone used 2. Suppose less than 2 not possible at all. So the 2 is called as chromatic number of the given graph. Graph coloring means vertex coloring. Graph coloring means vertex coloring. Until unless they will say edge coloring, don't go for edge coloring. Okay? Is it okay? Is it okay? Chromatic number of the graph. Edge coloring, don't take. If we say edge coloring, then only take. Chromatic number of the graph means to make, right, to give the colors to every vertex so that no 2 adjacent people contain same color. Minimum number of colors, how many you used. That is called chromatic number of the graph, which is also called as vertex color, right? Coloring and all. Because of you are little bit okay, can I move forward? Can I move forward? Yeah, fine. Now let's go to one more line. Let's go to one more line. Write down n colorable. Just try it only for namesake. N colorable. N colorable. What is the meaning? I will explain. To make the graph as colorable, if you use at most n colors, then I can say this graph is n colorable. To make the graph as colorable, you are using maximum n colors. Then I can say that, right, this graph is n colorable. Write down that line. To make graph as colorable, if you use at most n colors, then I can say that this graph is n colorable. Now again I'm asking you, this graph is n colorable meaning. This graph is n colorable meaning. I have a graph, someone said to me, this graph is n colorable. Is it lower bound or upper bound? I have a graph, one person came and he said to me, this graph is n colorable. Is it upper bound or lower bound? Upper bound. Maximum n colors. To make this graph as colorable, maximum n colors are required. Upper bound, upper bound, upper bound. Can you help me know? Chromatic number means upper bound or lower bound? Minimum number of colors needed. Minimum number of colors needed to make the graph as colorable. That is called chromatic number. But when you say n colorable, to make this graph as colorable, maximum it will take n colors. To make graph G colorable, we need maximum, means at least maximum n colors. Then we say that, G is n colorable. Fine, are you okay? Are you okay with this? They are very simple. One time listen, practice problems. One time listen, practice problems. To make graph G colorable, we need maximum n colors. Then we say G is colorable. Okay, perfect. Perfect. Now listen. Now listen, everyone. Everyone listen. Everyone listen. M and N, A, B, C, D, E, F, G. Can we help you know? Is it bipartite graph? Is it bipartite graph? Within M, no edge. Within M, no edge. Within N, no edge. Is it bipartite? Please help me, everyone. Is it bipartite? Is this graph is bipartite? Forget about is it complete bipartite or not. Is it bipartite? Is it a bipartite graph? If it is bipartite, listen, if it is a bipartite, do you believe or not, for the n people give one color. Because in the n, no one is adjacent themselves. For the m, give another color. So can I say like this one? Every bipartite graph is two colorable. Every bipartite graph is two colorable. Can I say like this? For all m people, give one color. For all n people, give one color. So, note, every bipartite graph is two colorable. Means maximum two colors. Now, can I say like this one? Listen, let us assume that chromatic number. you can use some notation, because every time writing this much big sentence, chromatic number of the graph, big sentence, who will write? So let us enter chromatic number, some x kind of thing, right? Let me write now. Chromatic number of bipartite graph. What is the answer? Less than 2, not possible. Chromatic number of bipartite graph. What is the answer? Chromatic number of bipartite graph. What is the answer? Can I say 2? Chromatic number of bipartite graph. Can I say 2? 2. Right? And one more thing is this bipartite graph. Let us enter number of vertices. Number of vertices. Right? Number of vertices. Every bipartite graph is 2 colorable. That is more than enough. Unnecessary confusion. Why? This is enough. This is more than enough. Every bipartite graph is 2 colorable. What is the meaning of 2 colorable? Every bipartite graph is 2 colorable. What is the meaning? Maximum. This is more than enough. Every bipartite graph is 2 colorable. Means maximum 2 colors. Maximum 2 colors. More than 2 colors. Any requirement of more than 2? Any requirement of more than 2? Every bipartite graph is 2 colorable. Right? Just write that line. Can anyone help me? Can anyone help me? What about null graph? Is it bipartite? Null graph, bipartite or not? No edge there, it's okay. It is also bipartite. But how many colors required? How many colors required? One is enough. For everyone give same color. Because no one is adjacent. No one is adjacent. Give to everyone one color. Right? That is the reason I written see this one. Every bipartite graph is 2 colorable. Means maximum 2 colors enough. Sometimes maybe 1. Depending upon right how the graph look like. How the graph look like. Every bipartite graph is 2 colorable. Maximum 2 colors are enough. Maximum 2 colors are enough. Minimum may be depending upon graph. If it is a null graph, 1 color is enough. Suppose using that at least 1 edge there. Bipartite graph, at least 1 edge. How many colors required? Bipartite graph, at least 1 edge there. Bipartite graph, at least 1 edge there. At least 1 means M to N edge there. Definitely, right, 2 colors are required. At the time 2. They will say in the problem clearly. Please careful. Every bipartite graph is 2 colorable. Means more than 2 colors are not required. Right? Less than 2 may be required depending upon graph. Suppose at least 1 edge there. Minimum also 2. At least 2 edges are there. Minimum also 2. At least 1 edge there. Minimum also, right? Right, 2 colors. Okay. That is also fine. I think until now. Just write this only. Extra no need to write. Bipartite graph. All M people 1 color. All N people 1 color. So more than 2 colors are not required. So every bipartite graph is 2 colorable. Can you help me now? Every star graph is a, listen, star graph with 6 vertices. Can I write to K15? Every star graph is 2 colorable. Can I say? Are we discussed? Na? Star graph is like this. Star graph is like this. We discussed it also. This is a star graph. Let me write that also. It is a star graph. It is also bipartite graph. A, B, C, D, E, F. So total how many people? I think 5 people. Outside 5, inside is 1. Total 6 people. Total 6 people, right? So star graph with 6 vertices can be written like this. 1 person is in the M group. All 5 people are in the N group. You can give like this. So colors, if you see, what are the colors? It is a C1. These all are C2. So 2 colorable. Fine. Every star graph is 2 colorable because it is a bipartite graph. Yeah, you can give, right? You can give. So what you want to say? Maximum 2 colors are enough. You want to say that. He is given boundary. He is given boundary. Can you help? No? Can I say like this one? Every star graph is 2 colorable. Can I say? You can give any number of colors, no problem. But can I conclude like this one? Every star graph is 2 colorable, of course. Because every star graph is a bipartite graph. Next one, every bipartite graph is 2 colorable, of course. You can give 3 colors also. You can give 4 colors also, no problem. Right. So you are given boundaries. Whenever you confirm, oh, 2 colors are more than enough. Any circumstance, any incident, 2 colors are more than enough. You can say it is a 2 colorable. See, whatever way you want, you assign the color. How many you want to assign, you can assign. But remember, 2 vertices cannot contain same color. That is called graph coloring. Next one. If you use minimum number of colors to make graph as colorable, that is called chromatic number. Remember, vertex coloring is called chromatic number. Okay, that is also okay. To make the graph as colorable, you are using maximum n colors. Then I can say that graph is n colorable. So from that I got to know that bipartite is a 2 colorable. Star graph also a 2 colorable because it is also bipartite graph. It is also bipartite graph. Is it fine? Is it fine? Yeah. And one more, let's go to one more small diagram. Let's go to one more small diagram. One more small diagram. Can you see this? Can you see this one? 1, 2, 3, 4. Can you help me now? Is K4 is planar graph? K4 is planar graph. K4 is planar graph or not? You know, right? Non-planarity will start from K5. Non-planarity will start from K5. K4 is planar. Everyone know. What is the reason? You can write outside. You can write outside. Outside people write as it is. Inside people you can write from outside. So you written like this, it will come like this. Now one more thing. In the complete graph, all the people are adjacent or not? In the complete graph, all the people adjacent or not? Normally, complete graph will take more colors. Normally, complete graph will take more colors because everyone is adjacent. Everyone is adjacent. Are you getting? Are you getting? Normally, complete graph will take more colors because everyone is adjacent. Everyone is adjacent. So please careful. Now see this one. It is a planar graph. Everyone know. It is a planar graph. Everyone know. Right? It is a planar graph. Now let's check the colors. C1, because of he is adjacent to all other people. C2, C3. Right? Because the reason some people are asking, sir, why are you giving C3, sir? Can't you give C2? These two are adjacent. Second vertex, third vertex already adjacent. I cannot give. What about this one? Can I give here C4 or C3? If I give C3, 3 having problem. If I give C1, 1 having problem. If I give in C2, I think 2 having problem. I have to give C4. It is a planar graph. It is a planar graph. Now let me check one more thing. One more thing I want to ask you. Listen, one more thing I want to ask you. 1, see this also. 2, 3, 4, 5. I am writing K5. I am writing K5. Check if anything missing. It is a K5. My intention is K5. Everyone is 4. Everyone is 4. Yeah. So remember everyone. It is a C1 because of everyone is adjacent. I don't have any other choice. I have to give 5 colors. Every person different color. Every person different color. Can you help me now? K5 required how many colors? 5. Any chance of less than 5? Any chance of less than 5? All are adjacent here. How can I give? That is the reason chromatic number. Now I can say chromatic number. Less than 5, no chance. The number of chromatic number of K5 is 5. Chromatic number of K4 is 4. X means chromatic number. Minimum number of colors needed. When you say 4 possible, 5 also possible. 6 also possible, 7 also possible, and so on. And one more thing, listen, one more thing, one note also there. Can you see this note also? Everyone listen. Can you see this note also? Can you see this note also? Here I am writing a note. See the note. Every planar graph. Every planar graph is 4 colorable. More than 4 colors not required. Every planar graph is 4 colorable. Remember this. Because of it is a planar, more than 4 colors not required. Every planar graph is 4 colorable. There is a theorem. Every bipartite graph is 2 colorable. Similarly, every planar graph is 4 colorable. More than 4 colors not required. Either 4 or less than 4. More than 4 colors not required. Either 4 or less than 4. It is not a planar. It is a non-planar. It may take more than 4. Right? It is a 4 colorable. It is a 4 colorable. No. Every planar graph is 4 colorable. Every planar graph is 4 colorable. It is a note. So take care. Every bipartite graph is 2 colorable. Every star graph is 2 colorable. Someone is saying chromatic number of a bipartite graph 1, depending upon what graph. I cannot say every bipartite graph chromatic number is 1. I cannot say this. Until unless you show, I cannot say this. Right? But I can say this one. Every bipartite graph, right? 2 colorable I can say. Because some bipartite graphs are there, 1 colorable also. Yeah, someone is saying that, can you explain this? See, every planar graph is 4 colorable. More than 4 colors are not required if it is a planar graph. Can you help me now? If you want to satisfy this condition, first of all, it should be a planar graph or not? If you want to satisfy this condition, first of all, it should be a planar graph or not? Please verify given graph is a planar or not. If it is a planar, you can keep upper bound. More than 4 colors are not required. If you think that it is a planar graph, more than 4 colors are not required. You can keep upper boundary. I cannot say lower boundary. Lower boundary, you have to check. Right. Array man, I written, see, non-planar, I written non-planar. Where below Vaya, below where Vaya. Yeah, fine, perfect. You didn't read properly. Right? Chromatic number of K5 is 5. It is a non-planar. Because of it is a non-planar, I cannot say 4 colorable. See, I cancelled also. Perfect. Any doubts? Any doubt check? Simple. 2 vertices, 2 adjacent vertices cannot contain same color. Like that, for every vertex you have to give color. Then I can say that story is called graph coloring. Right? So I given the graph coloring. Now, so for the given graph, with 2 vertices I can give color. With 2 colors I can give color. 3 colors also I can give. 4 also I can give. Minimum number of colors you are using to make the graph as colorable. That is called chromatic number. Right? So a graph is n colorable means maximum n colors are needed. A graph is n colorable means to make the graph as colorable, maximum n colors required. Minimum I cannot say. Bipartite, every bipartite, see this one, every bipartite is 2 colorable. I cannot say every bipartite is 1 colorable. I cannot say. But I can say every bipartite is 2 colorable. 2 colorable means 2 means less than 2. 2 or less than 2. Next one, I can say every star graph is 2 colorable. Every star graph is 2 colorable. 2 means either 2 or 1. Next one, every planar graph is 4 colorable. 4 or less than 4, depending upon what kind of graph. Fine. Can you help me? In all graphs, which graph will take more colors? In all graph, which graph will take more colors? You know very well. Note. What is the answer? Chromatic number of Kn is equal to n. Complete graph will take more because he is adjacent to all people. Am I right? He is adjacent to all people. So no need to confuse. Nothing. Any doubt there, ask. I may shout. I may play joke. Because of I repeated, you may ask that I will play joke so that next time you will be careful. It doesn't mean that you will stop asking doubts. Nothing will happen. Maximum, see, when I play joke on other people, you are laughing. When I will play joke on you, others also will laugh. Every time you only laugh or what? Yeah, I think Ross given one interesting answer. Every tree, listen everyone. Is it tree? Is it tree? Is it tree? Remember, every tree is 2 colorable. Root is C1, children are C2. Again, root is C1, children are C2. I think it is a bipartite graph. Tree is a bipartite graph. Tree is a bipartite graph. If you want, you can check. It is a C1, it is a C2. Again, these are C1. Again, C2. So, right, every tree is bipartite. So, 2 colorable. Nice point. Thank you. Anything else? Every tree is bipartite. Some people are saying, how can you say bipartite, sir? C1 I will keep in the M. C1 I will keep in the M. C2 I will keep in the N. Again, C1 people I will keep in the M. So you can keep alternative people, you can keep in the same group. First level, third level, fifth level, all odd number keep in one group. All even number keep in another group. Is it okay? Any confusion, let me know. Someone is saying K regular graph. Someone is saying K regular graph. Right? K regular graph. You can check once. Now let me go to the next one. One more. See this. See this also. See this also. 1, 2, 3. Can you see? Is it cycle graph? It is also cyclic graph. It is a C5. It is a C4. It is a C6. Now listen. One time listen this also. One time listen also. It is a C1, it is a C2, it is a C3. So chromatic number of this one, C3, is 3. But if you see this one, C1, it is a C2, it is a C1, it is a C2. So chromatic number of C4 is 2. Next one, it is a C1, it is a C2. Give alternative. C3, sorry. C1, C2, right? C1. Again C2. It is a C1. If I give C1, already that side C1, there it should be C3. Chromatic number of C5 is 3. Chromatic number of C6 is 2. Remember, chromatic number of Cn is equal to 2 if n is even, is 3 if n is odd. Check. Is it fine? Verify. Yeah. Is it okay? Is it okay? Is it okay? Someone is asking something. I will reply. I will reply, Atul. So whatever happened till now, are you comfortable? Whatever happened till now, are you comfortable? Please let me know. Make it fast. Array odd length cycle 3 yaar, even length cycle 2 yaar. Odd length cycle, someone is saying that it is a 2 regular graph. Am I right or not? It is a 2 regular graph. Everywhere degree 2 only. It is a 2 regular graph. It is a 2 regular graph. It is a 2 regular graph, right? But instead of saying 2 regular, see, 2 regular is a broad line, big line. Let's come to here. First of all, it is a cycle graph. Let's talk about cycle. Let's talk about cycle graph. Go one by one. If you jump directly somewhere, you will confuse. If you jump directly somewhere, you will confuse. Let's go one by one. Cycle graph. Right? I think odd length cycle 3, even length cycle 2, odd length cycle 3, even length cycle 2. If you want, you can check. So chromatic number of Cn is 2 if n is even, 3 if n is odd. If you okay, can we move to next? Johan, it is a 2 regular graph. Every cycle graph is a 2 regular graph. Can we move to next? Next. Right, perfect. Now I will give one problem. Now. You have to give what is the chromatic number. Right? Find chromatic number for the following graph. It depending upon what kind of graph, we can give upper bound. Lower bound, you have to check properly. See, we can give the theorems for upper bound purpose. If you want to find out the exact answer, means chromatic number, you have to use brain. No theorems will work out. You have to use brain. So let's start. I'm giving one problem. Let's start. Find chromatic number. Find chromatic number. Yeah. So take the graph. Find yourself what is the chromatic number for this. If you want, you can give some vertices names also. For your convenience, you can give. So A, B, C, D, E, F, G, and H. Find chromatic number of this graph. One small question I want to ask everyone. This is the given problem. Everyone listen. This is the given problem. Everyone listen. This is the given problem. Yeah. Everyone listen. This is the given problem. Is it planar graph? Say properly. Is it planar graph? First question. Anywhere edge crossing? Anywhere edge crossing? No. No edge crossing. So it is a planar graph. So it is a planar graph. Can I help you now? Every planar graph is 4 colorable. 4 colorable means not chromatic number 4. Maximum 4 colors. It is a planar graph. It is a 4 colorable. What is the meaning? Maximum 4 colors. What is the meaning? Some people are saying, sir, what it means, sir? Can you see this one? A, B, C, D. Listen, A, B, C, D. 4 options are there. 4 options are A, B, C, D. 4 options are there. See this one? 3, 4, 5, 6. He is asking, what is the chromatic number? Planar graph, 4 colorable. What is the meaning? Maximum 4 colors enough. So 5 cannot be the answer, 6 cannot be the answer. Can you help me now? What may be the answer? What may be the answer? Either A or B. It is a 4 colorable. It will give only boundaries. You have to check yourself. Is it 3 or 4? Please verify. Go ahead. Maybe 2 also. I don't know. Can you help me now? Can I remove 2 options? Can I remove 2 options? Because there is a C3. See this one. There is a C3. C3 required 3 colors. So 2 also not possible. Either 3 or 4. Verify now. Find chromatic number. By seeing problem, I can say, oh, it's a planar graph. So it's a 4 colorable. Means 4 are less than 4. So more than 4 can say. And one more, I am able to see C3 also. Somewhere there is a subgraph C3. C3 means 3 colors are required. If any option there, 2 are right less than 2, cancel it. So answer is either 3 or 4. Can you go further and check? Can you go further and check? Yeah, see this one? It is the C1. It is the C2. It is the C1. It is the C2. Okay. Is it okay till now? Till now, is it okay? Till now, is it okay? C1, C2, C1, C2. Everyone know. C4 required 2 colors. We done already. Now see this one. Everyone listen. Everyone listen. It is the C1. It is the C2. It is the C3. No other way to escape. And one more. It is the C2. It is the C1. It is the C3. So 3 colors are confirmed. 3 colors are confirmed till now. And one more, see this one, one more, it is the C2, it is the C1. Can I keep C3? Already C3 this side, already C3 this side. I think it should be C4. It is also C4. I think 4. If anyone say, sir, 3 is the answer, please let me know. If anyone say 3 will be the answer, please let me know. Sir, to me, 3 possible, sir. Please let me know if 3 possible. Please let me know if 3 possible. Because of planar, 4 are less than 4. Because of C3 there, so answer is 3 are more than 3. C3 in the graph, C3 there, 3 are more than 3. Planar, 4 are less than 4. So answer is either 3 or 4. I verified. It is compulsory saying that 4 required. Anyone can say 3 enough, sir. Can anyone say 3 enough, sir? Yeah, and one more sad news. One sad news is there I want to say to you. Listen. Chromatic number finding. Chromatic number of the graph finding is NP complete problem. That means no algorithm. You have to check manually. Chromatic number of the given graph finding is NP complete problem. No algorithm. You have to use brain. You have to use common sense. They will give very small graph only. They will give very small graph. They also knows that chromatic number is a NP complete problem. There is no algorithm. It is an undecidable problem. NP complete means no algorithm. It is an undecidable problem. Please careful. Everyone careful. They will give very small graph like this. If 3 possible, let me know. 3 possible, let me know. Yeah, I think outcuts some problem is coming. Outside some problem is coming. Please take care. Fine. Can we move to next? Can we move to next? Yeah, fine. Careful everyone. Yeah. Can you try one more problem? One more problem try. Find chromatic number for the following graph. Find chromatic number for the following graph. Yeah, can you go ahead? What will be the answer for this? Is it planar? Is it planar? Some boundaries. Reason theorems will do boundaries. Some people, if anyone try computer science, without using brain, you are gone. Without brain, you want to try something. Either it is a TOC, either it is algorithm, either it is a data structure or a discrete mathematics, anything. Without brain, if you try, you are gone. You have to use brain. Don't try to solve any problem of CSE without using brain. So try properly. Can you help me now? Is outside, listen, outside, because of it is a planar graph, answer is less than or equal to 4. It is a planar graph, chromatic number is less than or equal to 4. And one more thing. Is there any outside? Do we have cycle? Do we have cycle outside? Do you have cycle outside? Do you have cycle outside? Yes. What is that cycle length? Cycle length is even or odd? Cycle length is even or odd? Odd length cycle? Outside cycle, I think 5. 1, 2, 3, 4, 5. 5 length. So odd length cycle, I think 3 colors required. Even length cycle, 2 colors are enough. Odd length cycle, 3 colors. C1, C2, C1, C2, C1. If I write the C1, first one having problem, so C3. Just give alternative C1, C2, C1, C2, C1, C2. Last one, because of it is the odd one, I think C1 affecting. So 3 colors already confirmed. But if you observe inside, all are even length. Can you see even length means something like even length cycle means bipartite or not? Even length cycle means bipartite or not? I think they may be required only 2 colors. You can manage with the 2 colors. C1, C2, again C1, C2. Now it is a C2, it is a C1. It is a C2. Check. Anywhere problem verify? I think what is the answer? 3. Because of outside there is a odd length cycle. Odd length cycle means I think 3 colors required. Inside, if you see, all are even length cycles. Even length cycle means something like a bipartite graph. So inside 2 colors are enough. Right, fine. Let's see the one more problem. Yeah, take this problem also. One more problem. Example. Find chromatic number. Find chromatic number. Try. A, B, C, D, E, and F. All outside people connect. Inside there is a G. These 2 people are connected. These 2 people also connected. This is connected. This is also connected. This is connected. This is also connected. These 2 people are connected. These 2 are also connected. Yeah, try now. It's an exciting problem. It is an exciting problem. Try. Yeah, remember that also. They will be useful. Johan, they will be useful. Remember that. Make the problem simple. If it is useful, use it. See, instead of doing everything brute force, please use, if at all useful, read one time. One worst idea is applying every time brute force. True, that is also okay, right? Just learn those theorems also, maybe, right, in the point of examination. So they will give which one of the following statement is true. Option A, every bipartite graph is 2 colorable. Option B, right, every planar graph is 4 colorable. What you do at that time? They will give some statement, they will ask you which one of the following statement is true. Those are required. You cannot escape. It is better to know some valuable data. If problem is given like that, you can solve, that's fine. But if they give, find out which statement is right, which statement is wrong, how will you do it? Yeah. Can you go ahead this? Find chromatic number. Almost killing, yeah. So can you help me? Forget about A and D. Forget about A and D. Can you help me now? If you forget A and D, the left out diagram is it K5? If you delete the left A, right D, the remaining diagram is it K5? K5 means every person degree 4. K5 means every person degree 4. Yeah, let's try one time. See this one, it is the C1, it is the C2, it is the C3, because of there is a C, right? I think a 3 length cycle is there until now, C1, C2, C3. Right? What about this side? Can I keep C2? Yes, extreme corner. Can I keep C3? Extreme corner. Are you okay till now? I think he is adjacent to all these 3 people. Compulsory 4 required. D is adjacent to all 3 people. Fine. I think 4. C1, C2, C3, C4. Is it okay? See, let's do small parts. I know at anywhere cycle of odd length, 3 people required. At anywhere cycle of odd length, 3 people required. Fix them. You can adjust further. See this one, I think it is a C1, it is a C2, it is a C3. You may say that, sir, why don't you keep C2, sir? You have a problem. So C3. So why don't you keep here C1, sir? You have problem. C2, you have problem. C3, you have problem. So no other way, C4. Same replica, I think, right, left side also. Yeah, I think you really done good work. If anyone done mistake, rectify. They will give very small problem. Last year GATE exam also, this question is given. Last year GATE exam also, this question is given. After today's class over, you can check one time. Right, let's try this problem also. Chromatic number, find chromatic number. Try this also. Find chromatic number. A, E. Don't worry about answer. Whatever you are thinking, you try. Starting itself, how can you give correct answer? If you give, excellent. Remember, you have to use brain, no other way. Because there is no algorithm, right? All the theorems will give little guidance. Instead of doing blindly brute force method, please apply the logics, whatever is given. That's it. Yeah, go ahead. Go ahead with your knowledge, whatever possible you try. With your knowledge, whatever possible you try. Sometimes right will come, sometimes wrong will come. If anything wrong, you rectify. No need to criticize yourself. See, total society waiting to criticize you. Total society waiting. See, the people who are waiting to criticize you, first, right? First, mama is waiting to criticize you. Next, papa is waiting to criticize you. Next, bhaiyas are there to criticize you. Next, friends are there. Next, friends also there to criticize you. Next, your college also there to criticize you. Next, one more. Reddys are also there. Reddys are also there to criticize you. Arey man, these many people are there to criticize you. These many people are there to criticize you. Why are you criticizing yourself, yeah? Yourself also you are criticizing. The only person who, right? The only person who can save you is you only. Don't criticize yourself. These many people are ready, and one more, neighbors, major people are neighbors are always ready. First, neighbors are there to criticize you. Every day they will give complaint to mama, papa. Your son is like this, your daughter is like this. These are the major people. They are eagerly waiting to criticize you. These people don't have any work. They are eagerly waiting. Because of every day they are giving complaint to mama, papa, they will also start shouting. Right? Friends also, bhaiya also, everyone. Big society waiting to criticize you. Why are you criticizing yourself? The only one who should improve, right? The only one who can encourage yourself is you only. No one will encourage you. You only. The final hope of every person, himself. If you keep on saying, I am useless, everyone saying useless. You are also saying yourself useless. What is the meaning of that life? Yeah, other people are saying, okay, you are also saying, sir, I am incapable, sir. Reddy sir, I am thinking I am incapable. Reddy sir, I am thinking that I cannot do. Are you also saying yourself like this? Who will save you? The only savior of your life is you only. Mama, papa can give food to you. They can help you as much as possible from their side. Sometimes they will also criticize, right? These people also may not criticize. They are so innocent people. Mama, papa commenting is not good. These people may not criticize, but sometimes they will also do. So the only people who may not criticize you is a little bit of mama, papa. But remember, at any cost, you cannot criticize yourself. Always you should encourage, right? As soon as early morning you woke up, you have to say yourself, I can do it. At any cost, I can do it. I am capable. If you keep on saying yourself, I am useless, everyone is saying, I think I cannot complete syllabus, there is no way to save you. So remember this, every time you should encourage yourself. There is a big society waiting for you to criticize, right? To criticize you. Even you are keep quiet, these people always criticize you. Just leave all of them. You would try to improve yourself. Yeah, come here now. Come here. What is the answer of this problem? Find chromatic number. Yeah, I think by seeing this problem, listen, by seeing this problem, I can easily say one thing. It is a planar graph less than or equal to 4. It is a planar graph less than or equal to 4. And one more, right? It is a C1 color, it is a C2 color, it is a C3. I think minimum 3 colors. Maximum 4 already confirmed. Minimum 3 also confirmed. Answer is either 3 or 4. Minimum 3. By seeing this cycle, I got to know minimum 3. By seeing this is planar, maximum 4. Answer is either 3 or 4. Check further. Check further. What you want to say, please verify. Can I keep here C1? Yes. Can I keep here C3? Yes. What can I keep here? Can I keep C3? No. C1? No, I think C2. Yeah, fine. 3 colors are enough. Always encourage yourself. Don't say that, sir, I am thinking I am incapable. Don't say that I am thinking I cannot complete syllabus. Everyone will think like that. You may be thinking, you only thinking like that. All our students, all are like you. Some people will encourage them. Some people will suppress themselves. They will blackmail themselves. I am incapable. I am useless. Everyone is good. Everyone is good. I am only useless. If you do that, no one can save you. I know as a teacher, because of I am guiding from so many years, I know every student is similar. The only thing is, right, student S1 may not say to S2, but S1 will say to Reddy sir, I am thinking I am incapable. Reddy sir, I am thinking that I am incapable. Reddy sir, I am thinking that I am incapable. Reddy sir, I am thinking that I am incapable. They may not say each other, but they said to me, every topper said, I think Reddy sir, I cannot get the rank. I cannot get the rank. I am a lot of lagging. I feel I may not get. Array man, everyone is like this only. Do properly. Keep your 100%. After some time, you will say, Reddy sir, I completed half syllabus. Thank you so much for encouraging. Lastly, you will say, sir, I got below 100 rank because of you. It will be like this. Everyone is like that. The only thing is, S1 may not listen S2. But in between, right, everyone will say to him, right? Everyone will say to this person. S4 may not say to S1. S4 may not say to S2. But everyone saying, I am really saying to you, everyone like you only. Some people will express, some people don't express. Some people don't express at all. Suddenly they will come, they will say, Reddy sir, I attended every lecture. Every lecture I attended only recording. I didn't get opportunity to attend the live because of office and all. I got this rank. I feel so good. I feel so good. So everyone is like you only, no need to criticize. If possible, please encourage. If possible, you all people encourage each other. If anyone saying, I think I am dull and all, please encourage them. Don't discourage. Don't discourage. If anyone, one of your friends said to you, I am thinking I am not doing good work and all, please encourage them. You also, right? Don't worry about the other people. You also, please praise yourself every day. Can we move to next problem? Can we move to next problem? Give coloring. Yeah, that's what I'm saying, right? I think, see, someone asking one nice question. See this one. Someone asking one nice question, right? Sir, give coloring from outside for the same problem. That's what I'm saying. That's what I'm saying. There is no proper algorithm. Shakir, fine. So the answer of this one is fine. Can you help me now? Any proper algorithm? Outside, inside, any proper algorithm? To find the chromatic number, any proper algorithm, outside first, inside first, nothing like that. You give from inside, you give from outside, give whatever way you like. Whatever way you like, you give. right? So whichever will give less number of colors, that is our answer. That is our answer, right? Remember this. There is no proper algorithm. See this one, Shakir, whatever you said, I will say okay. If at all outside one will give less color. Anyone is giving less color than 3. Anyone is giving less colors than 3. Then I will take. Yeah, I think someone is saying that my doubt. So let's check. What is your doubt? So if anyone says outside giving, I am getting the better answer, then I will take outside. There is no proper algorithm. You have to check one by one. See, I went to that area. See, I know very well whether you start from inside, whether you start from outside. He required 3 colors. Odd length cycle required 3 colors. He also required 3 colors. So please check like that. V1, V2, V3, V4. Yeah. This is a graph G. This is a graph G which contains 4 vertices and how many edges? 4 edges. Am I right? This is a graph which contains 4 vertices, 4 edges. Is it okay? And don't link with the previous things. No relation with this and previous. Please make every day as separate. This graph contains 4 vertices and 4 edges. Can you help me now? 4 vertices. Do you know complete graph? 4 vertices. Do you know complete graph? Bhaiya, typo. Bhaiya, do you know complete graph? Complete graph with 4 vertices, K4. Do you know complete graph? Yes. This is the complete graph. Some other name. That graph different, this graph different. Don't link unnecessarily. This is some other graph. It may be G1 graph, some graph of G1. It is a G2 graph, which contain 4 vertices and 6 edges. 4 vertices and 6 edges. These two graphs are different. Right. Now listen, everyone listen. So G1 graph, listen, G1 graph, whatever is there, please help me. G1 graph contain how many vertices? Take all vertices as it is. G1 graph contain how many vertices? 4. Take all vertices as it is. Okay, I took all vertices as it is. Whatever G1 graph contain how many vertices? Take all as it is. Okay. Let us assume that it is a G3. There 4 vertices are there. Here also 4 vertices are there. In the G1 4 vertices. In the G3 also 4 vertices. It's fine. Can anyone help me now? In the G1, V1 to V3 edge there are not there. In the G1, V1 to V3 edge there are not there. Edge there. In the G1 edge there. Don't write if at all G1 having, G3 don't write. If G1 having any edge, don't write in G3. V1 to V2 edge there in the G1, yes, don't write in G3. And one more, V2 to V3 edge not there, then write. V1 to V4 edge not there, then write. Edge not there, then write in G3. V1 don't have edge, write in the G3. I'm repeating once again. G1 don't have edge, then write that edge. G1 have, then don't write in G3. Can you help me? How many edges came? You know very well. Whatever edge there previously 4 there, now those 4 cannot be here. Previously in the G1 4 people are there, those 4 people cannot be there here. So I think in the complete graph, totally 6 edges are there. Out of 6 people, 4 people are there in the G1, remaining 2 people will be there in the G3. Am I right or not? Remember. Then I can say then I can say graph G1 and G3 are complement to each other. Are complementary to each other. This is the meaning of graph complementation. If anyone asks, I have this graph, do complementation. G1 complementation is G3. G3 complementation is G1. See the beauty, see the beauty, see the beauty. G1, G3, if you do union, then what is the answer? G1 edges, G3 edges, if you do union, you will get the K4 or not, of course. In the K4, few people are there in the G1. Remaining people are there in the G3. If you take the union of both the people edges, vertices are same. If you do the union of the edges, you will get a complete graph. Now, it is a very interesting question. It is a very interesting question. Everyone listen. Very interesting question. Very interesting question. G5, G6R, G5, G6R complement to each other. Can you give the conclusion? G5 graph, G6 graph complement to each other. Can you say something about between them? What is the answer? G5 graph, G6 graph complement to each other. Can you say what are the things happening inside? What is the answer? Oh, G5 having 25 vertices. G6 also having 25 vertices. G5 having 25 vertices. G6 also having 25 vertices. And one more thing. If G5 having, listen, if G5 having 7 edges, now what will you do is complete graph first of all find out. From that complete graph, remove those 7 remaining edges you write in the G6. Then I can say G5, G6 are complement to each other. Remember, complement is not from one side, both the side. G1 complement G3, G3 complement G1, G1 complement G3, G3 complement G1. Complementation is both the side. Remember G2, listen, union of both the edges if you do, complete graph edges will come. Now because of your little bit okay, this is called graph complementation. This is called graph complementation. If you want, you can write on the top. Graph complementation. Graph complementation. G1 graph complementation is G3. That means G3 graph complementation is G1. Then I can say that G1 and G3 are complement to each other. Now, because of your little bit okay, I will ask you one question. Give an answer to me. If you are little bit okay, I will ask you one question. Please give the answer. See this one. If simple graph, listen everyone now. If simple graph G contain, if simple graph G contain 50 vertices and 70 edges, then number of edges in G complement how many? Then number of edges in G complement how many? If simple graph G contain 50 vertices and 70 edges, then number of edges in G complement how many? You can easily do that. Is there any issue? In the speed? Can I off the video? Can I off the video? Any issue from my side? Can I off the video? Arey Ashwini, can I off the video? Where is Shiva, one dog is there. Shiva, one dog. That dog will bark in the group. Entire day that dog will bark. There is a one dog is there, name is called Shiva. Entire day that dog will bark. In the group, entire day that dog is barking. correctly class time, that dog will stop. That dog stop barking correctly class time. Right? Before class, after class, that dog will bark. Someone asking kiss also. Arey man, his name is Pikachu. His name is Pikachu. He belongs to mechanical branch. His name, right? He is one of my student. His name is Pikachu. His name is Pikachu. He is one of my students. He is from mechanical branch. He is from mechanical branch. So first day onwards, I started guiding. First day onwards, he's a completely mechanical branch. First day onwards, I started guiding him. So he studied all the subjects from me. Right, first day onwards, he is keep on following. He taken me as a like elder brother. Sometimes he used to call at night 3 o'clock. He will say, bro, ready, bro. Sometimes he used to say, ready, bro, also. Right. I said, Are Pikachu, I am teacher, right? How can you say ready, bro? Bro, you only said, nah, bro, you are my bro. Bro, you only said, nah, you are my bro. I said casually in the class, it doesn't mean that I am your bro. I am a teacher, nah. I am teacher. How can you say bro? Night 3 o'clock calling, ready, bro. Can you explain this? How can you say bro? I'm your teacher, right? I'm your teacher, right? How can you say me like this? Then he said, bro, explain, bro. So he tortured me like this. Listen, he tortured me like this. Finally, he got rank. 18 he got. Finally, he got the rank 18. I thought he will get 1. He got rank 18. Then when the award ceremony is going on, he's saying that I want with Reddy sir only award. I don't want to take with other faculty. I want with Reddy sir only. I said, okay, I given to someone already. Some people I already given. AIR 1 I given, AIR 2 I given, AIR 3 I given. Right? So let them give. No, I want Reddy. He said in the meeting also, in the award ceremony also, he said, I want with Reddy bro only. Bro, come bro. He said in the award ceremony, bro. Okay, personally you said bro, I can understand, yeah. Personally you said me bro, I can understand. In the public function also you said bro. Then I am giving award. Right? I am giving award. He said, can you kiss me once? He only said, can you kiss me once? Reddy sir, can you kiss me once? His name is Pikachu. He said, Reddy sir, can you kiss me once? I said, okay, anyhow, bro only. If I kiss, what I will lose? He is my brother. If at all girl is there, she is my sister, right? Brother can kiss sister. Brother can kiss brother. What is there in that? He only said in the ears, Reddy sir, can you kiss me one time, please? Because I don't know, Reddy sir, when we will meet again. I said, okay, go ahead. Yeah, fine. So can we go ahead further? Please, can we go ahead further? Yeah. So let's start this. Some people are saying, sir, what is the answer of this problem? Where is he now? I think he's working in one of the company. In one of the software companies working. Right? He got lot of knowledge in the GATE coaching itself. You don't want to go for the masters. So he applied for companies. He got in one of the big company. He got a job. Something like Apple he got. Without going to IIT, he got Apple. Why he will go for Apple again? After MTech also, you have to go to Apple only. So he went directly. Fine, that's okay. But self-checking purpose he tried. Right? Fine. Let's see this. Let's see this. If simple graph G contain 50 vertices and 70 edges, then the number of edges in the complete graph, right? Number of edges in the complete graph, right? G complement is equal to. Then what is the answer? First of all, find out number of edges in. First of all, find out number of edges in Kn. Kn means here, what is the Kn? First of all, find out number of edges in Kn. What is the n value? 50 vertices. K 50, which is going to be 50 into 49 by 2, which is going to be 25 into 49. Whatever it is. Now number of edges in G complement is equal to 25 into 49 minus how many edges original graph having? 70. Yeah, can you check? Now, one more important thing I want to ask you, everyone. One more important thing I want to ask you. Can anyone help me? If I don't keep bracket, what will happen? If I don't keep bracket, what will happen? Let me say one time. If I don't keep bracket, what will happen is, everyone listen. If I don't keep bracket, what will happen is 49 purpose, how many people are fighting? Can you help me now? 49 purpose, how many people fighting? Fighting is always neighbors. Remember, fighting always done by neighbors only. Can you say 49 purpose, how many people are fighting? Let us assume that bracket not there. Let us assume that bracket not there. 49 purpose, how many people are fighting? 2 people. Who are those? 2 people are fighting. Who are those? No, neighbors only. Neighbors only. Immediate neighbor. Don't say numbers. 49 purpose, how many people are fighting? 2 people. Who are those? Operand purpose, operators will fight. Operand purpose, operators will fight. Who are those? Star operator minus operator. Who is the highest priority? 49 purpose, 2 people are fighting. Fighting done by right neighbors only, immediate neighbor. Operand purpose, operators will fight. Operand purpose, operators will fight. Can you help me? Who are fighting? Star and minus. Who is the highest priority? Star or not? So remember this one. To this person purpose, listen, 49 purpose, if you observe clearly, 49 purpose, minus also saying it is mine. Star also saying it is mine. Who is the winner? Star. So this will be done first. Whoever having more strength, they will take. Can anyone help me? Can anyone help you now? 25 purpose, how many people are fighting? 25 purpose, how many people are fighting? See this also. See this game also. 25 purpose, how many people are fighting? Array! Oi! 25 purpose, how many people are fighting? 2. Who are those? Equal also, multiplication also. Who is having more strength? This person also saying it's mine. This person also saying it's mine. Who is the winner? Multiplication. So star, right, from this side star is taken 25. From that side star is taken 49. So 25, 49. If you want, you can see operator list 2. Assignment operator, star operator highest priority. Star operator minus operator. Star is highest priority. Remember, fighting done neighbors only, immediate neighbor. Operand purpose, operators will fight. So see the answer. 25 purpose, assignment and star will take. Next one, 49 purpose, minus and star. Finally, the star got left side 25, right side 49. Right? So this will be done. With that answer, can you help me now? Let us assume that this answer is 25 into 49. Let us assume 25 into 49. Assume that 600. Can anyone help you now? Equal to 600 minus 70. How many people will do? 600 purpose, how many people are fighting? Can you help me now? 600 purpose, how many people are fighting? 2. Minus and equal. Who is the winner? Minus. 70 purpose, how many people are fighting? Only 1. If only 1, you have to give to him. If 2 people, then I will compare. If only 1, you have to give to him. So minus purpose, right? So right, 600 minus is taken. 70 also minus taken. Finally, this is done. Now that answer will be assigned. Now it is the correct time to ask you. Bracket there, bracket not there. Any problem? Bracket is there, then also same answer. Bracket not there, then also same answer. Am I right or wrong? Bracket there, then also same answer. Bracket not there, then also same answer. Am I right or not? Whenever you feel forcefully, I want this. Actually, something going on, you want something else, then bracket required. With brackets also same answer. Without brackets also same answer. You no need to keep bracket. Can anyone help you now? Bracket may, listen, interesting answer. Bracket may smaller priority also higher priority, higher priority also smaller priority. If I keep bracket, smaller priority also become higher priority, or higher priority also becomes smaller priority. Bracket make smaller to higher or higher to smaller. Bracket makes higher to smaller or smaller to higher. Bracket makes smaller to higher. Some people are asking, sir, how, sir? How can you say bracket will make smaller to higher? See this one. If you want, you can check. If I keep bracket like this, listen, if I keep bracket like this, see, comparing star operator and minus is the less priority. But because of I kept bracket, it will be done first. At any point of time, if you want to make smaller one as bigger, keep bracket. If you want to make at any point of time smaller one as bigger, keep bracket. Now I think I am giving one simple example. You may be thinking you are small kid. Listen, you may be thinking you are small kid. You may be thinking you have less knowledge. You may be thinking you are incapable. You have these many problems, right? I think video I have to on. I have to on video for this. You may be thinking you are less capable. You may be thinking that you are useless. You may be thinking comparing other people, you are waste. You may be thinking like that. These many problems, get one GATE rank. You will go to IIT. Then everyone will say you are great. Just add IIT. That's it. Just add IIT. Then you no need to say any proof also. No one will ask you. No one, if you say I am not capable. After going to IIT, see this one. After going to IIT, if you say I am not capable, no one will accept. Indirectly you are saying you are capable. Indirectly you are saying you are talented. Indirectly you are saying comparing with other people you are great. So by adding that bracket, it will give more priority. Someone is saying, sir, why we need to worry about priorities here? Because here simple mathematical calculations are right. The reason is, see this one. If priority not there, let us assume that priority is not there. Assume. Can you see if priority is not there, you may do subtraction first, afterwards multiplication. You may do multiplication first, afterwards subtraction. Can you see both the answers are same or different? Multiplication first, then subtraction. Subtraction first, multiplication. Both are same or different? Different. How can you say why we need to worry about the priorities? If priority not there, someone is saying that BOD-mass rule. Someone is saying that no BOD-mass, no GID-mass. But yeah, sometime it will go wrong. Hidden. As a kid you remembered it. As a kid you remembered BOD-mass rule and all. Sometimes it will fail. So the best idea, whatever, right? Listen, school method, of course, that time maybe they will be useful. But now in the BOD-mass rule, in the BOD-mass rule, any arrow operator. In BOD-mass rule, any arrow operator. In BOD-mass rule, any arrow operator. No, that's what I'm saying. BOD-mass, no BOD-mass, no GID-mass. They will work for small kids. You are a CSE person. Please, can you see the priority list one time? Every day, little bit you see. See, initial day I kept little bit. Next day I said little bit. So slowly at the end of the C programming, you will get more clarity. At the end of the C programming, you will get the more clarity. Every day I will say little bit. One day if I say, you may not get anything. Right? Fine. Last time I want to ask you. For this problem, if I keep bracket, if I don't keep bracket, any change? For this problem, for some problem may not be. It is not necessary everywhere you will keep bracket. It is not necessary everywhere you will keep bracket, right? So please check, really bracket required. Or you want to do, listen, you want to do this first. See this one. You want to do this first. Next to this, is it same thing going on? In the mathematics, is it same thing going on? Of course. First star operator and minus operator, star having highest priority. So whatever you are thinking, same thing is going on, then why bracket? Suppose you are thinking something else going on, then keep bracket. Okay, fine. Right? So sometimes no need to. Some people are asking, sir, if I keep bracket, is there any problem? No problem. Without bracket also same answer, with bracket also same answer. Then why are you increasing one operator more? What is the need of increasing one more operator when our answer is same? Now, can you say the final answer? What is the answer finally? Calculate properly. Calculate properly. What is the final answer? 1155. Perfect. This is called complement graph. G complement contain how many edges? Now, one more beauty. Listen, one more beauty. G contain 50 vertices. G complement contain how many vertices? G contain 50 vertices. G complement contain how many? 50. When you don't study properly, you may do complement of that also. Complement of a given graph is, right? Vertices are same. Edges only different. And one more thing, I will go back and I will write once. Right? G1, G2 are adjacent to each other. G1, G2 are adjacent to each other. See this. Then I can say G1, G3 are adjacent, right? So, sorry, G1, G2 are complement to each other. What is the meaning? The meaning of this one is, see this one. Edge E1 belongs to G1, assume. Then if you see here, edge E1 not belongs to G3. That is the meaning. Edge E1, right? That is the edge E1. Edge E2 not belongs to G1. Then edge E2 belongs to G3. Fine? Is it okay? Is it okay? That is the definition. So then what about what he says? Listen, what about what he says? Every vertex for all x, where x belongs to, for all x belongs to vertex set V. Here all are there. Here also same. For all x, where x belongs to V. Same thing will be there. All vertices. Every x, right, belongs to G1 will be there. Yeah, if anyone thinks that, otherwise you can write easiest way, right? I don't want to make complex. You can write easiest way. If you think that's something complex, leave it. Simply all vertices should be there. The notation is creating problem. Just write all vertices. I will write that. Vertices same number of vertices. Here also same. Edges only difference. Here edge not there, here reverse. Here edge there, here not. Fine, you know this very well, right? That is called complementation. Because of your little bit okay, now I am moving further. Can I move next? You are okay with the complementation. Can I move next? Remember, only for simple graph. Can you help me now? Multigraph contain how many edges? Multigraph contain how many edges? Yeah. Infinite minus is infinite. Multigraph contain infinite edges. Infinite minus infinite. So we don't say anything to multigraph. Every discussion, whatever we are doing, only for simple graph. Until unless they will mention the multigraph, don't think anything about multigraph. This is the first slide, Ross. Ross, this is the first slide. Can we move to next? Let's move to next. Let's move to next. Let's move to next. Let's move to next. Yeah, the next topic which is going to come, see, simply definitions. Just understanding the definitions one time. Don't do any research. Trust me, it is not one subject to do research. It is not two subjects to do research. 13 subjects. 13 subjects literally. If you keep on doing research, it never ends. Can you help me now? One subject to do PhD, how many years required? Suppose in one of the subject you want to do PhD, how many years required? PhD is how many years, Bhaiya? Bhaiya, PhD is how many years here? 4 or 5 years. 5 years PhD. If anyone saying that, sir, I will study this subject thoroughly, 5 years for one subject, 13 into 5, 65. 65 years you have to study. Arey, buffoon, are you getting? One student called me and he said that, sir, I like this subject. I will do more research. Then why are you writing GATE? 13 into 5. You may say that, sir, 3 months I will complete. Arey, man, when you started doing research of any subject, it never over. It is required 5 years PhD. You want to do PhD after going to IIT do. You want to do PhD after going to, right? After in the MTech you do. In the MTech also, listen, in the MTech also you cannot study. In the MTech totally you have to study again, right? I think approximately 6 subjects. See, in the BTech, 4 years BTech, how many subjects you studied? 50. 4 years BTech, you studied 50. Approx. 4 years BTech, approximately 50. Now in that filtration done, right? Overall, 13 subjects enough for GATE exam. Some filtration. Some subjects are unnecessary, right? You can leave. Now after these 13 subjects are over, if you go to IIT, you will study out of those 13, 4 subjects. In MTech, you may study 4 subjects, whichever you like. 4 subjects you will study. Now if you go to PhD, you will study 1 subject. Are you getting? If you go to PhD, sir, do we have classes every day in MTech? Go to MTech and get to know. What should I say to you? Go to MTech and check. Right? So 4 years, see this one. MTech 4 subjects. MTech 4 subjects. Right? PhD is 1 subject. This 1 subject 5 years here. Suppose if you complete 2 years here, 3 years here, totally 5 years. Right? You can study 1 subject thoroughly, do PhD 5 years. Don't do here. Every subject you have to study in such a way that, listen, you have to study in such a graph theory. Right? Don't by heart, meaningfully go. Meaningfully, whatever I will say, one time study, then see PYQs. In any PYQ, if you are troubling, post in the group. If you do like that, right, everything is perfect. Just go graph theory. Oh, graph theory. So whatever nodes is there, first complete. Next one, right? As soon as it is over, I think every test, before every test to revise. We can test discrete mathematics, revise. Next one, simultaneously do PYQs also. Any problem troubling, post in the group. Right? Fine. Perfect. Now I think you are okay. Now come to next one. Very, very interesting one. Can you see this? Very dangerous also. Very dangerous also. Very dangerous also. Can you see this? Can you see this one? P Q P Q R S. PQRS. And one more. It is a G1. It is a G1. See the next one. One more. A, B, C, D. It is a G2. G1, G2. G1, G2. Observe properly. Observe properly. G1 contain how many vertices? Observe properly. G1 contain how many vertices? 4. G2? G2? 4. So here 4 vertices are there. Here also 4 vertices are there. Next one. G1 contain how many edges? 3 inside, 3 outside. 3 inside, 3 outside. Just listen 1 minute. Someone is calling. I don't know. Yeah, fine. So G1, G2. G1 contain 4 vertices. G2 also 4. Can you help now? G1 contain how many edges? Inside 3, outside 3. It is 6. It is 6 edges? Yes. Here it is also 6 edges. Now one more beauty. One more beauty. These 4 people, can you say G1 contain 4, G2 contain 4. Vertices are same, edges also same. I am very happy. Can you help Can you say the degree sequence? Can you say the degrees 1 by 1? Can you say degrees 1 by 1? Any order you can say. P degree. Any order, okay. P degree 3. Q degree 3. R degree 3. S degree 3. Right? Can you go here? Any order, okay. Any order, okay. Can you say A degree 3. B degree 3. C degree 3. D degree 3. Can you help These are same. Degrees also same. Degrees also same. And one more thing. Very interesting question. Is G1 contain 3 length cycle? G1 contain 3 length cycle. G1 contain 3 length cycle. Cycle, right? 3 cycle of length 3. G1 contains cycle of length 3. If you want, you can check. G2 also contains cycle of length 3. Am I right? ADC cycle is there. And one more thing I want to ask you. G1 contain how many 3 length cycles? Can you count? Cycle of length 3, G1 having, G2 having. How many cycles are there? G1 having how many cycles of 3 length? G1 having how many cycles of 3 length? Check here. G1 having how many cycles of 3 length? This is 1. Let me write once. This is 1. This is 2. This is 3. Am I right? 3? 3 or 4? Outside is one more. 4 cycles of length 3. 4 there. Am I right? Cycles of length 3. Cycles of length 3 here also. Okay. Next one. Cycles of length 3. 4 there. Cycles of length 3. Right. 4 here also. Check 4. Some people are asking, sir, where, sir? Let's check. 1, 2, 3, 4. Am I right? Am I right? Bhaiya, am I right? There also 4. Cycles of length 3, 4 people there. Here also 4 there. Now some people are asking, sir, what about 4 length? Let's check. Can you help Is there any cycle of 4 length in the G2? Is there any cycle of length 4 in G2? In the G2, right? Length 4 cycle there are not there? There. What about G1? G1 having cycle of length 4. I think there. See this one? Can you check here? 1, 2, 3, 4. Am I right? Am I right? PQRS. Yes. Here also cycle of length 4. Here also there. Here. Vertices are same. Edges are same. Degrees also same. Next one. Number of cycles also same. Length of the cycles also same. Array man, see this one. It is a very difficult to list out. It is a very difficult to list out. I am saying one thing. Everything same. Then those graphs are said to be isomorphic graphs. Two graphs are said to be isomorphic graph. Everything same. Isomorphic graph. That is the meaning. If anyone asks what the meaning of isomorphic graph, simply say everything same. Same graph another way. Someone is saying number of 4 length cycle. Let's check that also. If at all you are right, then you are right. I given randomly. Anything can happen. Can you help me now? In the G1, how many 4 length cycles? In the G1, how many 4 length cycles? Check properly. Here, there means they are also possible. See this. See one time. Is it right or not? Let's check. Is it right or not? Let me check. Is it 4 length cycle or not? Let's verify. Is it 4 length cycle or not? See this one. 1, 2, 3, 4. Am I right? 1, 2, 3, 4. Am I right? Arey bhaiya, you are unable to see. There you are. You are unable to see. There you are. See this one. 1, 2, 3, 4. Start from here. 1, 2, 3, 4. Are you getting? 4 length cycle. Here 4 length cycles, how many? There also check. Now it is the correct time to ask you. When two graphs are said to be isomorphic graph. Two graphs, I am writing here. Two graphs, G1 and G2 are said to be isomorphic graphs. Are said to be isomorphic graphs. If two graphs G1 and G2 are said to be isomorphic graph, if two graphs G1 and G2 are said to be isomorphic graph, if can I help me? If everything same, simplest way this only. If everything same, can you help me? Listen everyone now. Two persons are equal. Two humans are equal. Is it possible? Impossible. Two persons are equal. Is it possible? Is it possible, bhaiya? Two persons are equal. Is it possible? If I want to calculate two people are equal or not, if I start calculating, see this one. If I start calculating, I have to check. Right? I think person A knows there. Person 2 also knows there. Person A knows 2 holes are there. Person 2 also 2 holes are there. 2 eyes there. 2 eyes there. Next one. How many 8 strips are there? That much. How many 8 strips are there? That much. Right? Next one. Right? How many ears are there? Arey man, everything. Difficult to say. Two graphs are, can you help me now? Two graphs are isomorphic to each other or not? Is it difficult or easy? Two graphs G1 and G2 are said to be isomorphic graph. If everything same, everything so big, only namesake I have to list out, I listed out. Namesake I have to list out, I listed out. Can you help me now? When you start checking, what you check? You have to write. Simplest way of writing is everything same. Everything same in terms of not look wise. Can you help me now? Algorithm can see or algorithm will check. Please give answer to me. Don't think like a human. Human can see. Can you say algorithm can see or algorithm will check? Algorithm will check. You don't see. Sir, look-wise both are different, na? Who asked you to see with eyes? Algorithm cannot see. It is your problem. You should behave like, listen, whenever you are writing a algorithm, you should behave like you are a blind person. Whenever you are writing a algorithm, you should behave like a blind person. See, blind people are correct people to write algorithm because nothing they will see. They will see like this. Two people are equal. Two people are equal. Okay, one knows, okay, one knows. They will check like this one, blind people. They cannot see, na? They will see blind people. Oh, this person. Oh, one nose, right? Okay, two holes are there for nose. This also two noses are there. Right? How many strips are there? Okay, 75. How many are 75? So everything checking only. Computer cannot see. Everything is calculation. You may say that, sir, look-wise different, na? Who asked you to see with eyes? It is a computer. Computer will see everything calculation. Now, can you help me now? If you want to check two graphs are isomorphic or not, what is the easiest way of saying? Everything same. Just know me something different. One difference also they are not isomorphic. They are not isomorphic. Now, can you list out when you are checking two graphs are isomorphic or not? Can you say first criteria what you check? You can check any order, no problem. Can you list out a few? Please, you have to write in your notes. Otherwise, after some time, you may forget. Can you see the first one? Vertices are same or not? Check. Same. Afterwards, you will forget. You can simply write one line. Everything is same. Everything is same. You may forget what is everything same. So at the end of the day, you have to compare. Vertices are same. Second one, edges should also be same. Degree sequence should also be same. Next one. If at all is having 3 length cycle, you should also having 3 length cycle. If at all is having 3 length cycles 4, you should also having 3 length cycle 4. If at all is having 4 length cycle, you should also having 4 length cycle. Right? Next one. You check here. Can you help me? How many 4 length cycles here? Can you check? Someone is saying any other way or technique. I will let you know. Jaya, I will let you know. Can you say here how many cycles are there? Can you check 4 length? Outside is 1. Now I want answer from you. Please say total edges how many? That's what I'm saying. Total edges how many? 6 edges. Total edges how many? 6 edges. Yes. Can you help me now? If you go to the G2, total edges are 6. Outside cycle, if you take how many edges over? Outside edges you take 4 length cycle will come. How many? 4 over. G2 I am talking. Totally 6 edges. Outside people only take 4 edges are over. You have remaining 2 edges. Can you help me now? Using these 2 edges, listen. Using these 2 edges, let's check. How many possible? I will try once. So I want to come here. Can you help me? I want to come here. Can you say 4 length cycle I want? See this one. 1, 2, 3, 4. Can you help me now? Whenever you are creating cycle here, how many edges you used? Outside is 1 cycle. I am very happy. When you are creating cycle here, how many edges you use? 1. See this one. I think let me write once again. 1, 2, 3, 4. Many ways maybe there. I use it like this. See this one. 1, 2, 3, 4. Can you help me now? Whenever you are creating cycle here, are you using any new edge? Outside is 1 edge. Any new edge you use? Any new edge? Are you use inside 2 people new? Any new people? At least 1 new person should be there. See, same thing you cannot take once again. You cannot say that is a 1 cycle. At least 1 edge will be different. If all are same, you cannot say same cycle don't count. Can you see this one? Some people are saying one interesting thing. I am writing here with different color. I am writing blue color. I am saying. Can you see this one? Edit 1 cycle. See everyone. 1 cycle. Yeah, it is one 4-length cycle. Some people are doing like this one. What some people are doing is they will start from here. Listen, they will start from here. They will come like this. They will say it is one cycle. Arey, bhaiya, at least one edge should be different. Yeah, at least one edge should be different. When you are saying that that is a 4-length cycle, this is also a 4-length cycle. At least some edge should be different. If no edge differ, it is a one only. If no edge differ, one only. Is it okay? No edge differ, it's a one only. At least one new person should be there. At least one new person. So some people are asking, sir, with the inside I can try one more. Let's see. Inside. 1, 2, 1, 2, 3, 4. Can you say at least one new edge there? At least one new edge there. Bhaiya, at least one new edge there. Yes. Inside 2 new people came. Outside things, right? Outside things are 4. Out of them 2 you are taken. 2 more inside. So like that you count. Because if I verified many times, I came with a very simple conclusion. They both are isomorphic. Because I done many times. If you want, you can verify. How many cycles G1 having a 4 length? G2 also same story. Next one. If at all first one having 4 length cycle, he is also having 4. If at all first one having only 2, right? Second also having only 2. Check if you want. Right? Now last one, easiest way of saying 2 graphs G1 and G2 are said to be isomorphic graph if everything is same. 2 graphs G1 and G2 are said to be isomorphic graph if everything is same. Everything same means what? Just start checking. Vertices are same. Edges are same. Degree sequence same. Next one. If at all first one having cycle, second also should have cycle. First one don't have cycle. Second also don't have cycle. First one having 3 length cycles are 25. Second also having 3 length cycles 25. Next one. First one having 4 length cycles are 3. Second also having 4 length 3. Anything differ. If you say to me, sir, this is differ. Not by look wise, by property wise. Every property is on. Everything should be same. Everything means what? You may ask that everything is what? I will only for namesake I will list it out. Everything. What he says should be same. Edges should be same. Degree sequence should be same. Next. Cycles are same. Right? Cycle, both should have cycle. Right? Next, let me write. Number of cycles same. Length of the cycle same. Anything and so on. Some Mahabharata will be there. Mahabharata will be there. I cannot list out. You may say that, sir, it is missing, sir. Of course it will miss. Everything where I will. See, listen, I am comparing 2 humans. I am comparing 2 humans. See this one. Nose I will compare, eyes I will compare, mouth I will compare, ears I will compare, ear also I will compare, hands I will compare, fingers I will compare. Everything I compared. Everything over. I said everything perfect. They both are same. Then doctors will say that their kidney is not same. Doctors will say that their kidneys also have to compare. Their heart also you have to compare. It is a very difficult. I cannot list out all. Everything same. I can list out few. Some people are asking. Then how to check 2 graphs are isomorphic or not? That is the reason. It is an undecidable problem. It is an NP complete problem. Checking 2 graphs are isomorphic or not. NP complete. If at all any question will come in the GATE exam, they are very easy only. Don't worry. They are very easy only. Don't think much because within 2 minutes, whatever possible, they will give. Within 2 minutes, whatever possible, whatever possible, they will give. Research problem, they don't give. Wherever you find, from today onwards, if you find out, wherever you find out isomorphic, right? If you are not clear, post in the group. If you are not clear, post in the group. Right? One more thing is you can go to exampreptool.com. You can go there. There also you can post. Exampreptool.com. You go there. There you will find out, right? In the options, you will find out practice questions. Practice questions are there. There you will find out, right? There you will find out. Ask a doubt. Ask a doubt. You can post there. In the app also, you can post this also. After posting, right? Share it so that you can see everyone answer. Otherwise, questions, when you are posting the questions in the group, they are going, one is here, one is here, one is here. So that, right, they will ask, right, when you are posting a question, practice question, ask a doubt, they will ask the subject, discrete mathematics, you select, then post discrete mathematics question, and there is a share button, share, keep that link in the group, so that everyone will go, they will give their answer. Fine, do from now onwards, so that all your doubts will be there. If you think it is a tough question, don't keep the dust. If you think it is a very tough question, right, lot of time it will take, please post like this. Easy question, post in the group only. Tough question, post in the, right, post in the website, share the link so that you can see your answer by, right, what people are giving answer. Tough questions only post, easy questions you can post in the group. Is it okay? Is it okay? Tough questions only post, so that you can see all the people comments. All the people comment. I will see all of them. Whichever is the correct answer, that one I will keep the answer. I will make it as verified. I will make it as verified. This is the answer, so that you can verify also. Oh, how it is correct answer, you can verify. Only tough questions post. Dust don't post. Otherwise, it will also become dust. Now, if you're comfortable, can I move to next one? I will give one problem, one of the GATE problem, right? I will give to you. You can verify. One of the GATE problem I will give now. You can verify. Can I give it? Checking two graphs are isomorphic or not, right? So write down. Write down. I'm copying the problem. One of the GATE problem I'm copying. So take this. Let's see how many people will give answer. This is the graph. Graph G. Name is G. Find isomorphic to G from the following. Option A. Option B. Option C. So no need to scare. No need to scare. Scaring person never win. Scaring person never win. Life is full of problems only. You may be thinking problem will come now only. No, bhaiya, it will come always. Sir, some people are saying, sir, when the problem will stop, sir? When you die, then problem will stop. When I die, then my problem will stop. When I die, my problem will stop. That is the only place where problems will not come. Sir, I don't want problem, sir. Then die. Reddy, sir, you also don't want problem, then you die. No, I want problem. If any problem will come, I will rectify. If you are afraid to problem, you never grow. Every day problem will come. Every day. I am able to see every day problem. Please remember this. Every day problem will come. That is the meaning of, oh, you still alive. Problem not coming means you are not alive. Don't worry anything about answer. Whatever you know, whatever you understood, try. Don't think unnecessary. Some people are overthinking. Arey, stop overthinking, man. Do overworking. Do overworking. Stop overthinking. Overthinking leads to you nothing. Overworking, at least you are right. You are improving day to day. Yeah, this is the problem. I think perfect. Yeah, can you check? For the given graph which are isomorphic, because if it is not possible to show everything, I am showing, right? See this one. That is a given graph. Option A, option B. First to check. Move down a little bit. Yeah. So I can make, I think, a possibility there. I will compress. Now check. Is it okay now? Everything same. If you are facing problem, others also facing problem. Sir, I am so scared, sir. My answer is right or wrong. Others also. Not only you, human being, everyone human. Not only you eating food, everyone eating, everyone sleeping. Everyone is like you only. Don't think yourself that some special kid. God is created with so many drawbacks. No, yeah, everyone having same. Sometimes you are wrong, sometimes they are wrong. Sometimes you are right, sometimes you are right. Try to do as much efficiently as possible. Don't guess. Use brain, whatever best possible, do it. Yeah, one small question I want to ask you. In the given graph, how many degree ones? In the given graph, how many degree ones? 2. 2. Degree ones 2. In the option A, degree ones how many? 3. You have to check everything. Degree ones are here 2. Here degree ones are 3. So A gone. Here degree ones are 2. Here degree ones are 2. Here degree ones are 2. Okay, fine, perfect. So one option is gone. Can you help me? In the given graph, how many vertices? 8. In the given graph, how many vertices? 8. Check 8 vertices are everywhere there. 4, 4, 4, 4, 4, 4. Yeah, that is also fine. Can you help me now? In the given graph, degree 4, 1 person there. In the given graph, degree 4, 1 person. In the given graph, degree 4, 1 person. In the given graph, degree 4, 1 person. Am I right or wrong? In the given graph, degree 4, 1 person. Now in the option B, any degree 4. In the option B, any one degree 4. No, this is wrong. Here degree 4 possible. Here no 4 at all. Can you see here degree 4 possible? Yes. Here degree 4 possible? Yes. So I think either answer is either B or D. Answer is either B or D. Let's check further. Let's check further. In the given graph, 5 length cycle possible? In the given graph, 5 length cycle possible? In the given graph, 5 length cycle possible? Here possible? 1, 2, 3, 4, 5. 5 length cycle possible, but here 4 length cycle only. So this is not. They also know it is an undecidable problem. They also know that it is an undecidable problem. It is an undecidable problem. They also knows this. They will give easiest one. Their only goal is, listen, their only goal is, are you using brain or not? See, you only say, what formula I will say here? What is the way of solving this problem? Using brain, using common sense, believing yourself. You have to believe, even though you are so talented, you don't believe, nothing will happen. Every time I have doubts, see, when I am teaching, listen everyone now, sometimes, remember this, sometimes I will teach wrong also so confidently. That is the meaning of believing myself. Because I am thinking this can happen. I'm thinking this can happen because no one is God here. If I assume I don't want to do any mistakes here, assume I don't want to do any mistake, then don't do any work. The only way where you are not doing any mistake is you are not doing any work. If you are doing, definitely some mistakes will happen. Sometimes, Sir Reddy, sir, you said in the classroom something like this, right? I think I got this one, some counter example. I will try my level best, not giving anything wrong. In the flow, sometimes maybe small mistake happen, right? That is the reason I created one group also. Anywhere, if you find out anything like that, post in the group. If really it is my mistake, I will say sorry. I will also rectify. In the flow, anything can happen. Because of I have used experience, mostly no mistakes will be there. If one or two things also there, I will rectify. You also do mistake, I also do mistake. Because of I done many times, I will do less mistakes. Because of you are doing first time, you may do more mistakes. Okay, if you okay, I can move to the next problem. If you okay, I can move to the next problem. Can I move? Can I move? Someone is saying that, someone is asking something. Sir, while considering degree sequence, we should consider only same set of values or not. So that's what I am saying. Hidden. There is no hidden, right? There is no rule like you have to do this only. Small degree, how to compare, big degree, how to compare. By seeing eyes, you have to get idea. Can you help in the given graph? See, I got something like this. In the given graph, degree 4, one special person there or not? In the given graph, degree 4, one special person there or not? Degree 4, one special person there or not? Degree 4. I checked, oh, only one degree 4. Let's see. Maybe if I am lucky, it will work out. I verified. Degree 4 not there. In the first A graph, then degree 4 not there. In the second one, degree 3 not, degree 4 not there. If I am lucky, whatever I taken immediately may work out. If I am unlucky, maybe some more time extra. There is nothing like you have to check. Some people are asking, why are you checking degree 1 only? You check anything, yeah. Degree 2 you want to check. Degree 1 you want to check. Degree 4 you want to check. Anything is fine. There is no rule. You have to do first this, second this, third this. Everything same. Everything should be same. Then only it is the isomorphic. Then only it is isomorphic. Sir, I will check the cycle first, sir. If you are lucky, if you take the cycle, you may be right. You will get advantage. Can you guess? If you see the cycle, given graph contain 5 length. Who have 5 length? Given a graph contain 5 length. Who have 5 length? Check. Some people started with the cycle first. That is the reason. There is no rule. You have to start this only. Start anything. Given a graph contain 5 length. Who have 5 length? B and C. So you can cancel directly A and D. Directly A and D cancel. Now B and C, who is the correct answer? Go further. So I think given graph contain 4, right? 4 degree, but in the C 4 degree not there. C 4 degree not there. So C is gone. Then B is the answer. You start from any side, no restriction at all. That the reason, listen, that the reason I used to feel like this. That the reason I used to feel this. Listen, that the reason I used to feel as a computer science student in the GATE examination. As a computer science student in the GATE examination, you should get minimum 50 marks after attending all our lectures. Minimum 50 marks you have to get, because if you use only common sense, just use only like this, you know what is the meaning of isomorphic. Oh, same. Then check, use common sense. If you use only common sense in all the subjects, you will get 50 marks. Minimum 50. Minimum 50. Don't by heart at all. Just applying common. First, you have to understand the definition. Okay, right? Isomorphic means both same. Do few examples. Without by hearting, do few examples. Now, keep on practice. In the examination, one of the thing will come. Right? If you do more practice, problem you will do fastly. If you do less practice, problem you do slowly. See, some people hand may not move in the exam. Why? They didn't done practice. Some people hand will move so fast. What is the reason? They didn't done the practice. Fast means they done the practice. Slow means they are not done the practice. Some people are asking, sir, isomorphic, I listened the class. 2 problems you said. I got clarity. Can I go in the isomorphic directly in the examination? Do 5 more problems so that you will see all kind of samples. So that in the examination, one of the sample will come. More practice, you are more close to the path. More practice, you are more close to the path. Fine. Can I move next? Do more practice, you are more comfortable. It doesn't mean that one subject you will do again and again. Every subject you have to do like this. Every subject you have to do like this. Now come to the next. Very interesting. Very interesting. Come to the next. Everyone listen. Come to the next. Careful. Yeah, I will write here. 1, 2, 3, 4. 1, 2, 3, 4. One, two, three, four. 1, 2, 3, 4. Yeah. So this is the G1. This is the G2. G1, G2. G1, G2. Right. Now let me ask you one by one. One by one, let me ask. Careful. One by one, let me ask. Everyone observe. Everyone observe. G1 having 4 vertices. G2 also 4. Careful. One more nice point. G1 having 4 yeah, 4 vertices. G2 also 4 vertices. Careful, everyone make it fast. G1 having 4 vertices. G2 also 4. Respond. G1 having 4 vertices. G2 also 4 vertices. Yes. Next. G1 having 3 edges. G2 also 3 edges. Go ahead, go ahead, go ahead. Fine. Edges same. What is a same? Edges same. Next one. One more. G1 don't have cycle. G2 also don't have cycle. Right? Next one. Next one. If you see the G1, let me write the degrees in the decreasing order. Let me write the degrees in the decreasing order. If I see the G1, degree 2 there, degree 2 there, degree 1, degree 1. If I see here, degree 2 there, degree 2 there, degree 1, degree 1. Degree sequence also same. I written in both of them decreasing order. Degree sequence, what is a same? Edges same. Cycle concept also, both don't have cycle. Degree sequence also same. I think I can say both are isomorphic to each other. It is a very simple graph. It is a very simple graph. Are they isomorphic to each other? Are they isomorphic to each other? If cycles are there, I could have verified cycle. What I will verify further here? Are they isomorphic to each other? And one more beauty. Listen, they are isomorphic to each other. I am happy. They are isomorphic to each other. Listen, everyone. Interesting answer. Interesting answer. To this graph G1, G2 is isomorphic. For G1, G2 is isomorphic. For G2, G1 is isomorphic. Right? Both are isomorphic. I am okay for this. Both are isomorphic. I am very happy. But one more beauty. Can I say both are complement to each other? Both are complement to each other. G1, 3, right? Complement. See the complement. Vertices are same. See the edges. 1, 3 edge there here. 1, 3 edge not there. Next one. 1, 2 edge there in the first one. 1, 2 edge not there in the second one. Whatever left side person having, right side person not having. Left side person cross people not there. Right side people cross people are having. They are complement to each other also. Remember, for the given graph, careful, for the given graph, if you do complementation and given graph and complementation, if both are isomorphic to each other, this is called as right, self-complementary graph. Self-complement, it is a complement to itself because this one same. This one same, self-complementary. If I do complementation, I will get myself. Self-complementary graph. Self-complementary graphs. Some people are asking, what is the meaning of self-complementary graphs are? Right? Let us assume that I am a G1. I done the complementation. I got G2, which is equal to G1. G1 complementation is G2. Interesting thing is G1, G2 both are isomorphic to each other. I done the complementation, I got G2. But interesting thing is G1, G2 both are isomorphic to each other. So this is called self-complementary graph. Very simple. A graph which is complementary to itself. A graph which is complementary to itself. See, both are same. You may be thinking both the graphs are different. No, both are same. A graph, right? This one. For the given graph, if I do complementation, I got itself. That is called self-complementary graph. Now, interesting answer. Listen, everyone now. G1 graph contain 5 edges. G1 graph contain 5 edges. I want answer from you. G1 graph contain 5 edges and G1 is self-complementary. G1 is self-complementary. After complementation, how many edges he have? G1 having 5 edges. G1 is self-complementary to itself. Now, after complementation, how many edges? 5 only. Because both are same. Self-complementary means what? Both are same. Both are same. You have to write the definition properly. I am reading the definition. If G is isomorphic to G complement, then G is self-complementary graph. That's it. Write that one. If G is, if otherwise if G1, if G is self-complementary, if G is isomorphic to itself, if G is, just wait. I'm repeating. If G is isomorphic to G complement, yeah, isomorphic to G complement, then G is self-complementary. It's better to write definition also because afterwards you may be confused. If G is isomorphic to G complement, then G is self-complementary graph. Namesake write one time. You already knows. Only for namesake you write. I given with the help of example. G1 complementation is G2, which are isomorphic to each other. Very easily I said to you. Definition, safe side, I written the definition also. If G is isomorphic to G complement, then G is said to be self-complementary graph. Yeah, perfect. Yeah. Can I move? Can I give one problem on this? How problem look like? Can I give one problem? Can I give one problem? Right. I'm giving one problem. I'm giving one problem. Someone is saying, yeah. Time is over. Yeah. One problem I can give. One problem I can give. Take it. Take the one problem. If G is self-complementary graph with n vertices. If G is self-complementary graph with n vertices. If G is self-complementary graph with n vertices, then find number of edges present in G. Can you complete this problem? Try this problem. I don't know how many people will give answer. Try what answer you are going to give for this. Try what the answer you are going to give. Can I give answer? Bhaiya, can I give answer? Someone is saying, sir, does the chart auto scrolls for you? No, Bhaiya, to me also same. To me also same, yeah. To me also same, yeah. That is the reason don't see the chart that much frequently. Don't see the chart that much frequently, right? Nothing will happen. Just you give answer. Just you give answer. When I shout, see. When I shout, then only see. Fine. Can I give answer now? Can I give answer now? I think many people are given answer, right? I'm very happy. Many people are given answer. See this one? See correctly? If G is self-complementary graph with n vertices, then find number of edges present in G, right? So yeah, the interesting thing is n vertices is given. So number of edges possible in Kn find out. N into n minus 1 by 2. Number of edges in Kn is n into n minus 1 by 2. You know very well. In this half, in one graph, in this half in one graph, another half in another. Am I right? If you add both of them, complete graph should come. If I add both of them, complete graph should come. Here also n vertices are there and edges are these many. Here also n vertices are there, edges are these many. Fine. The very simplest answer, very simplest problem. Everyone given answer. I'm very happy. Can we move to next? Can we move to next? Over. Can we move to next? Yeah, see the next one also. Try this. Try this. A cyclic graph on n vertices. A cyclic graph on n vertices is isomorphic. A cyclic graph on n vertices is isomorphic to its complement. A cyclic graph on n vertices is isomorphic to its complement. Then find n value. How will you proceed? Can you do it? A cyclic graph on n vertices is isomorphic to its complement. The value of n is So what is the answer you are thinking? A cyclic graph on n vertices is isomorphic to its complement, then find n value. I will try. I will try. Same thing. Same model. I will try one time. See this? See this one? Number of edges in Cn plus number of edges in Cn complement is equal to number of edges in Cn plus number of edges in Cn complement, right? Is going to be n into n minus 1 by 2 total. So number of edges in Cn is n. Because of he said that a cyclic graph on n vertices is isomorphic to its a complement. So I think complement also having n is equal to n into n minus 1 by 2. So 2n is equal to n into n minus 1 by 2. So nn cancel. Nn cancel. Right? So n minus 1 is equal to 4. N is equal to 5. So, okay? You may say that, sir, cyclic graph n vertices, cyclic graph with n vertices, how can you say n edges? You take any cyclic graph. 4 vertices are there, 4 edges. Because of it is isomorphic to itself. Means here 4 edges are there, means isomorphic also should contain 4. Here n edges, here also n should be there. Why? How it became this n? Isomorphic to, it's a complement. 2n is equal to n into n minus 1 by 2. Right? So simplification you can do very well. Fine. Is it okay? Today morning, as soon as I started taking the DS class, but this problem came. This problem, right? It is not supporting Wi-Fi. I am so scared, right? So I don't know how to take the class. You people may not having problem, but I have problem. But I don't know what is the actual reason for this. I thought, let's relax. Let's relax. I hope you all people relaxed. Fine, na? Yeah, C class not required, right? Within few days, DS will be over. Then we will start C in our platform. Then we will start the C in our platform. Until now, whatever happened, can you, right? Can you revise all of them? Until now, whatever happened, can you revise all of them? Major portion item. Pointers is the major topic is pointers only. Major topic is pointer only. These all are small things, right? I will make 3 classes maybe. I will make 3 classes, 3 in our platform also. Until that time, please can you revise all the things, whatever happened. Whatever happened, can you revise? Why we cry at 9:30? Why we cry at 9:30? What mistake we done? What mistake we done? Is it okay? Fine, is it okay? Please revise. Please revise. Please revise. Whatever happened, please revise. Right? Fine. Thank you. Thanks, everyone. Thank you. Good night. Take rest. Remember, your rank is decided by, I'm really saying, your rank decided by, see this one. Your rank is decided by, how much fastly you will complete syllabus. Syllabus completion. Syllabus complete fast. Syllabus complete fast. If you complete syllabus fast, you will get a better rank. You will get the better rank. Don't compare with others. They started someday, you started some other day. Don't compare with others. You push yourself. You push yourself. Syllabus complete fast. That will decide your rank. If you complete little early, if you complete early, you will get the more better rank. And one more important thing, simultaneously practice questions also. If anyone do this blunder, you are the victim. Practice I will do at the end. What is end here? What is the end? When you complete syllabus, you don't know. Some people problem is this. They don't know when they complete syllabus. They will say, I will do practice at the end. What is the end? Can you clarify? Please clarify me what is the end. End I will do practice. When the end are? No one knows when you complete syllabus. No one knows when you complete syllabus. So my suggestion, completed subjects practice. See, right, upon that subject 1 completed practice. Subject 2 completed practice. Subject 3 completed practice. Simultaneously do PYQs. Simultaneously do weekend test. I still remember Abhinav. Right? Abhinav, I still remember. While studying, simultaneously done the practice of PYQs also. Subject S1 completed. He is doing PYQs. Right? He is asking all doubts and all. Then he said to me, sir, I am completing the, right? As soon as any subject over, I am doing practicing simultaneously. I said, okay, go ahead like this. When syllabus over, practice also is done. You don't have, lastly, you don't have time because he got job. You don't have time also. He is not done the practice enough. The only thing what great he done is, whenever syllabus is going on, subject completed practice PYQs, subject completed practice PYQs, subject completed practice right weekend test. He is keep on doing this, keep on. Syllabus completed. He done all PYQs. Last 4 months he went for internship, because in their college internship is mandatory. So no practice also. Still he got All India rank 1. Reason is that systematic planning. Some people are saying, sir, I don't do practice now. At the end I will do. At the end, GATE exam over, I will do practice. Arey buffoon, do practice now. Simultaneously do practice. Atul, do practice simultaneously. I am so happy with some people who ever doing practice in the group. I felt so happy. Please do practice. Every weekend test you write. Atul, are you came? Atul not came. Abhi came. Chalo then. Chalo. Atul came. Yeah, good boy, but not good by health. That is the reason you didn't return the big chart. Big message you didn't return means you are not good. I can understand. His health is really not good because he didn't return the big message. Big message, if at all he is more energetic, we cannot digest that. There is a big message. Mahabharata will be there. Yeah, get well soon, Atul. We want to see your big message. Eagerly we are waiting your Mahabharata. We are really waiting for Mahabharata. Chalo.